And I guess the software company that Stephanie founded was really different. It was founded with innovation and inclusion at its core. It was a contract programming company that recruited people to work from home. And so it broadened the workforce to accommodate the people, the women and some men as well, who were at home kind of caring for children and other dependents as well, and for whom that conventional office environment just didn't really suit them. And it was around that time in sort of the late 60s that she realized that her given name, Stephanie, was sort of doing her no favors in this kind of male-dominated industry. So she took up her husband's suggestion, which was to start signing off all of her communications as Steve, which was actually her family nickname. And the business kind of started rolling in. So Steve started the company as this way for her to avoid the sexual harassment and lower pay, the injustice of lower pay that she'd endured and experienced in previous roles. And the company flourished into this community of people all over the country who were just interested in the same sort of things and came to become this kind of community of people. And it's female friendly, the company's female friendly reputation and sort of female led reputation welcomed LGBT employees and provided that sort of flexibility for families and, you know, and carers that lots of people still battle for, 50 years later. Nowadays, it's widely recognised that equality, diversity, and inclusion is a really positive force. You know, we know that, studies cite that there is improved business decision making, improved performance, better ability to innovate, and of course, a broader pool of talent to recruit from. And all of these years later as well, we've only really just begun to discover what Steve and her employees knew all along, which is that working from home really doesn't mean compromising on performance or productivity. So 50 years ago, Steve's company was this huge trailblazer whose employees went on to program the black box for Concorde. And Steve knew that by tapping into this underutilized workforce and creating this kind of community around ideas and values, that was enough to achieve success. And she really successfully coordinated, thousands of people dotted all across the country who are writing code from their kitchen tables, from their spare bedrooms, and using really innovative ways of working to develop software and deliver projects. So I hope this is beginning to sound a bit familiar. I think that the NHS-R community is a fantastic trailblazer, and it's so ably created the sort of energy and enthusiasm and convened so many of us. We're all sat this morning in our offices or our kitchen tables or our desks or our basements, all across the country, and then further across internationally as well. We've got a fantastic whole host of international speakers at the conference this year. And I think that we've been able to do this, or the NHS-R's been able to do this, because we all believe in a common purpose, this shared mission to learn from one another and to promote the use of open source technologies to address the problems that we all face working in the health and care system. And there are, of course, many problems that we are facing. The health and social care system in the UK was already under immense strain, and it's now facing renewed pressures as we emerge from the pandemic. So, the direct disease burden of COVID and its long-term impact on our health is something that we're all concerned about. We're only still, beginning to understand the impacts of long COVID, which affects almost 2% of the population of the UK. And the indirect disease burden of the pandemic as well, worsening mental health, that's placing immense pressure on the system. And existing health problems are becoming worse. There were 4 million fewer elective care procedures in 2020, so the waiting list is growing, and there are ongoing wider pressures around the workforce and financial issues that also need urgent attention and investment. And this is all happening amidst persistent structural inequalities and social inequalities, which have been thrown into stark relief by COVID. Not to mention that we also have the period of renewal and reform in England's health and care system coming this coming year. So much to manage, I suppose. So what can data analytics offer? What can we do as a community of analysts and multidisciplinary allies? What can we bring to the table? And how should we be equipped to be tackling these problems head on? So I've picked a handful of opportunities here that I think could help support the system and brace it for the challenges ahead. So first of all, improving productivity by automating low value work. This requires investment and focus from central bodies and local leaders to improve fundamental infrastructure and carve out development time. And I suppose really that sort of opportunity offers us the chance to elevate our capacity and capability as analysts. And we recently, the Health Foundation recently published a long read on NHS productivity, and it's how agility really is a huge factor in productivity. And it noted that while the sort of shiny, sexy, cutting edge applications of tech, those are the ones that often kind of bask in the glow of the spotlight, but there are really important productivity gains to be made for applying tech to administrative tasks. So, you know, those high volume repetitive tasks like appointment scheduling, prescription management, patient feedback analysis. And so Mohammed touched on some of those just earlier in his intro, but the Nottingham team have been funded by NHS-R to develop a solution to that last issue of patient feedback analysis. And so they're developing a machine learning approach that tags incoming patient feedback automatically. And that means, of course, faster, more efficient processing of the information coming in. So those coders are freed up to do, you know, other bits of work. But it also means it's an easier route to narrow down searches for NHS staff when they're looking at improving different services. So it sort of greases the wheels for service improvement in that way. And we all know the potential of this kind of work, but what I think we need is a sort of concerted effort from the top to the bottom to commit to investing in fundamental infrastructure that supports data quality and timeliness and the sharing of tools. We should also be looking to establish effective environments that facilitate innovation both within and across ICSs. So, for example, committing to providing analytics teams with, you know, the free capacity to reflect and to learn from others and to engage in strategic thinking. So, promoting ownership of change, you know, as well within teams is a really vital ingredient of success. I've funded 44 projects now through the Advancing Applied Analytics Awards, through that award program. And we've kind of seen really consistently that where analysts and clinicians and patients and managers alike, where we all feel empowered rather than done unto, you know, success sort of follows. We should all really be brought into those new ways of working. And I know analytics and technology produces benefits, not in isolation, but when embedded and you know, used effectively, and it can you know, require considerable effort to understand how those different roles work with each other and how we kind of amend processes and ways of working to accommodate that. But I think it's really important that we keep ownership as a really important factor of innovative environments going forward. And fostering innovation, of course, also requires meaningful development opportunities for analysts, which are tied to career frameworks. And I know there's obviously a huge swell of momentum for this work at the moment with the work being undertaken by AFA, NHSX and NHCEI. So that's really wonderful. And we certainly will need some effective leadership to navigate through the coming years. And we have lots of it in spades, but I think we do need more chief analytical officers. I say this every year and I will continue to do so. And I think we need more multidisciplinary analytics champions. We have got a beautiful pipeline of new leaders that could be, you know, on our conference program. So what is it that we can do to support them, to identify them, to help them become the leaders of the future? And in terms of the system itself, of course, we are moving into that period of renewal and change, as I just mentioned, but I think this gives us an opportunity to understand how analytics is best kind of valued and organised within ICSs. So those ICSs give us a good opportunity. And the strategy unit, I know Pete's about to speak after me, but the strategy unit has just published a really excellent report which describes different recommendations to advance analytics and analytical capability. And among those recommendations is the recommendation to have kind of a national learning week every week, to have protected time, a national learning week every year, and to have protected learning time across the workforce for analysts, and also to have a chief analyst within an ICS that make up these regional networks. And I think these recommendations really underline the importance of having really standardized approaches to training and skills development, because it's so easy to have these things on your to-do list and you slip away because more important, more urgent things come through. We've all had that happen. So these kind of standardized ways to adopt these changes are kind of key to furthering the cause and embedding analysis really as a valuable tool for the years to come. And it's also important that we recognize that leadership doesn't just begin and end with our system and our colleagues. Patients and the public have a really important role to play. And so meaningful engagement and involvement with them is going to be really, really vital if we're going to begin to start working in different ways to tackle these problems. And finally, I'm going to talk about collaborative, safe and timely data science at scale and how that should underpin much of this. This isn't just about promoting the sharing of tools openly and learning from colleagues, both national and international. NHS-R and other communities are doing that really, really well. But this is about timely, granular data being linked and made available safely and securely, not just to analysts in the system, but also to researchers and innovators. Trusted research environments are already being used, to great success elsewhere. So how do we begin to understand what that looks like at a system scale? Can we learn from the GP data and planning research program, which is going to be implemented with a trusted research environment? In terms of federated analytics, we can begin to work across ICSs to identify and analyse health inequalities and issues of poor health stock that could support the delivery of timely insights to policymakers and decision makers. And finally, if we were to commonly use reproducible analytical pipelines as a standard approach, would that begin to dissolve the issues of duplication and replication that we so often kind of experience and hear of? We've already seen this used successfully in other communities, so how can we learn from them? I've made really titanic demands there, sound so simple, but I'm going to get onto the crux of my talk, which is to kind of describe how NHS-R's strengths and attributes really position it uniquely to address these challenges as a change maker and as a practical builder of capability. So the NHS-R community is founded on the fact that we can all come together to work differently, better, quicker, collectively, and that by combining our voices together and learning from one another and influencing decisions at the top, we can establish change and really see a different future for analysis. And I think that these strengths and attributes that position it ideally to be a change maker are around its kind of its future focus, its innovation, its disruptive approach, its kind of collective approach to learning, and its drive for quality and value as well. So the community in its relative infancy, Mohammed just spoke about the fact that we are kind of only a couple of years in. It's already influenced and disrupted the landscape of policy and delivery in health and care analysis in the UK. It's proudly driven by quality and value. We know that if we can tap into this collective skill set, we can begin to identify and quickly solve those tedious problems that, eat into productivity and produce those duplications of workarounds. And the NHS-R community, the NHS-R solutions, are a really, really good example of that. Clearly, a core tenet of the community is to support learning. The workshop programme is an utterly stellar, I think it's 25 workshops, isn't it? It's an utterly stellar way for us to kind of begin to build our skills, but also Slack, Twitter, training, this conference, these are all really, really important channels for us to diffuse knowledge and to build our skills. And as the community grows, I just really hope that these attributes and strengths remain a really consistent, powerful presence, and that as an inclusive community of diverse and skilled colleagues, we are encouraging one another to innovate, to disrupt, to promote quality and value, and to learn for the years to come. So finally, just on to capability building, the NHS-R community really has quite quickly become an important component of a very evolving landscape. You know, we're seeing the publication of major strategies that are setting out really ambitious plans for the role of data analytics in the system. But fundamentally, we know that capability, unfortunately, is still lacking for many analytics teams. And we can think of capability as really hindered by issues of supply and issues of demand. So factors that contribute to the supply of capability are things like data access, access to tools, poor diffusion of methods, you know, lack of development opportunities, and this kind of fractured siloed working. And I think that the NHS-R community really addresses all of these quite well. You know, the funding available through the solutions opens up opportunities to ring fence time and to create tools with peers. And simply, it's so powerful, simply just valuing that time and having those pots of funding is sort of transformational for capability, because it kind of says, you know, our innovating and creating new tools is worth our time, and it's worth our
Okay, unfortunately, Ellen's frozen. Can I ask Peter? Peter, are you ready to speak?
I think I am, Mohammed. Yeah.
Okay, thank you. I think if we can switch to Peter, please. So Peter, if you can start sharing your screen. And if I can ask our WTV colleagues just to contact Ellen and reassure her that we've moved to the next speaker. Peter, over to you, please.
Hi, Mohammed. I'm just trying to get to where I can do a decent job of oops. Are you still there?
Yes, we're still here, Peter.
Can you see my screen?
Yes, we can, but you're not in presentation mode yet. So if you want
no, that's what I'm trying to do.
Top left hand corner, there's a little screen button. Or
hold on a second. My problem is I can't see what I'm right. Yes, there's something blocking my ability to get to that.
Oh. Okay, what about the okay,
is that okay? No.
Try F5, somebody's saying.
F5. Oh dear. I hate sharing screens. Can you not see anything at all?
I can see your slide deck. Peter, just work through your slide deck.
I'm just going to go with this because honestly, anyway, hello everybody. I'm Peter Spilsbury. I don't need to say this at the beginning, but so I'm director of the strategy unit. I'm not an analyst. I did my entire degree without touching a computer. In the days before I think they were invented, but they certainly weren't in wide use. And I was just hearing the description of the process improvement that people are involved in now. So when I first joined a regional health authority in 1983, the way in which we did a letter, if we wanted to send a letter out to the clinicians in our patch, we hand wrote it. We put the handwritten script in the internal post, which went to the top floor of the building to the typing pool. They attempted to translate from the handwritten script. They sent their first version back in the internal post. It came back down to you. You hand wrote a series of amendments on one of the carbon copies, put it back in the internal post. It went back up to the top floor. They then did another version. That process repeated itself until you'd got to a copy you were happy with. And then the process of sending the letter out was them producing multiple copies through carbon sheets, putting them in envelopes, sticking stamps on them and taking them to the post box. So it's amazing how processes develop. But anyway, through my career, I was always interested in data analysis. I did health economics at university, and I've had the privilege throughout my career to be able to find and support brilliant analysts and to try to create the space and the opportunity for them to use their skills to address useful questions for the NHS. So what I want to do today is to just tell you just very briefly about the strategy unit, which is the team I run now, and how I came to R through the strategy unit. And then to tell you a little bit about what we're doing in the Midlands region. Ellen mentioned it earlier, to essentially try to create the space and the permissions for people to do what Ellen described. And I'll come back to what I mean by that.
Peter, can I just check, are you moving your slides forward?
I am. Can you not see that?
No. Can I make a suggestion that you perhaps only do audio if possible, because your voice is coming in and out as well. But the slides are not moving, at least not for me. If anybody else can check that they're moving, just say something in the chat. Yeah, they're not moving.
Well, this is really weird.
Okay, so that.
Let's stop sharing again, Mohammed. Try and start again.
No, the problem here is we're seeing your speaker's notes, and we're fine with this. If you're happy with this, we're fine. Just carry on with this, Peter. That's good.
Can you see the slides?
Yeah, we can see the slide. This
okay.
Is good. Fine. So
I'm happy, but I just can't get out of this.
If you move the slide on, let me just.
Yeah. What can you see now?
I'm on slide number 4, the learning box.
That's fine.
Fine.
Good.
Okay. Carry on. Sorry for the interruption.
No, that's all right. Let me go back to this one then. So the strategy unit is an NHS team. We happen to be based in the Midlands, though we're in the ether now, but we're an NHS team that's been going for about a decade. And we specialise in what's described on that slide there. So analytical work, evaluation work, decision quality work, and we do that on a pay for project basis. So even though we're all NHS employees, that's the basis on which we work. And we're now headed towards being a team of about 50 people. I just wanted to give you a couple of examples of the role we're trying to play in relation to R. So this is a blog I wrote in 2020 about this notion of a learning NHS and my frustration about how much analysis that the NHS was commissioning is effectively black box analysis, can't see under the bonnet. And the argument in this blog, and this is a sort of fundamental guiding principle for us in the strategy unit really, is that a fundamental principle of the scientific method is replicability of analysis. And we all know that through the scientific endeavour, that is the route to how to advance knowledge. And that means if we're going to have learning systems, which is one of the latest buzzwords in the NHS, if we're going to have integrated care systems that are learning systems, they have to reject black box analysis. And what that means is that when NHS analysts do the work or when the NHS commissions others to do it, there must be an imperative that that work is fully published with full transparency of method, and wherever possible, that method is set out using open source code. So on our website, which you're welcome to have a look at sometime if you're interested, we put as much of our work on our website as we can, the work, rather than sales pitch descriptions of it. So under our publications, just to give you an example, one of our recent ones looking at socioeconomic inequalities in access to planned hospital care. If you go into that report, which has got all the results, all the method, all the arguments, and you get to the end of it, you'll find this. So the analysis, the data and the analysis was all set out using R and has all been published so that it's available to fellow analysts to take that work on, develop it, use it, apply it locally. So that, and this is becoming our standard practice with the analytical work that we produce. And then, as Ellen mentioned, we were recently commissioned by NHS England to do some work looking at how to advance analytical capability in the NHS and and its partners. And we produced this report in October, which again is now on our website. And one of the proposals in that report is set out there, which again is that there should be an active promotion of the principles of open source analysis and replicability, and to ensure that the implications of that are understood across NHS leadership. We found in some of our surveys analysts in the NHS whose organisations wouldn't let them use R, wouldn't let them put it on their computers. So we have to break past that, and we have to develop a leadership community that understands what it means to support an analytical learning culture for the NHS. And just to mention in that report, I mean, I do invite you to read it, and I'll come back to that at the end, but we also set out a kind of typology of the types of analysis that the NHS needs to be able to do, which are the bits described in blue there. You don't need to worry about the detail, but we basically describe 5 types of analytics and the pillars that need to be in place to support that. So problem structuring, data management, communicating results, enhancing decision making, because the only purpose of analysis, folks, is to support better decisions. And alongside that, we described a high-level skills framework for an experienced data analyst in the NHS. And you'll see in there, again, we're saying that the familiarity and use of R should be a fundamental expectation of data analysts in the NHS on entry, and that's what we ought to be looking to promote. So this thing about creating space, the thing that struck me throughout my time in the NHS is that many analysts, perhaps most analysts, are passionate about what they do. They're very skilled, they have a great deal of capability. But if the system around them squashes them and doesn't think about how to create the space to allow them to apply their skills and their trade, then they will essentially struggle, and they will end up spending a career doing what I call performance management theatre or contract ping pong, and they won't be spending their time trying to address useful questions. So we've started down a journey in the Midlands. This has been going for about a year and a half now, where through discussion and conversation that came out of some shared work that everybody did on population health management, we've established a proposition that each of our ICSs sets up a team. They can set it up in whatever way they want. They can call it what they want, but we've called it a decision support unit for the sake of this initiative. And essentially they think about creating a team that can support them to make high quality strategic decisions, i.e. the ability to draw insight from analysis, access knowledge and evidence effectively, know how to translate these into action, but also how they can be supported to become a learning system, which I think essentially for us means be good at evaluating what they do, learning from their own initiatives, but also actively collaborating with others. And we see these teams as a fundamental platform for how to create the capacity, capability and culture that's needed to make that happen. And again, just picking up Ellen's point, we're really clear from the outset that this is about demand and supply. So the role of our decision support units and the network I'll describe in a minute is also addressing how we can build the capability of decision makers, of leaders to appreciate, commission and understand effective analysis, alongside how we can build the capability and capacity of our analytical community and support their continual learning and development, alongside how we can pool that resource effectively to get some scale benefits without squashing the life out of everybody. So each system to bring together a decision support unit, which is focused on their key strategic challenges. It's a cross-system thing, not a top-down thing, and it needs to be led by a chief analyst. that doesn't matter whether that's the title, but it needs to be led by someone who's an effective analyst. And the sorts of questions that we would imagine these teams would be supporting their integrated systems to look at would be things like, what are the most significant inequalities we face? At what point in the pathways are those inequalities occurring? What might be the most effective methods for addressing them given the evidence? How might we learn through trial and error whether our initiatives are effective in addressing these inequalities? How do we properly understand variation and use it to target improvement? How might we better understand on a robust basis what the views are of our population on the risks they're willing to support, on the choices they might be prepared to make, on the trade-offs that they think the NHS should consider? How do we understand how the health and care system interacts with the wider economy? If we redesign our outpatient function, how do we think that might impact on productivity in the wider economy? Those sorts of big questions, important questions. And then the proposition is that each of these decision support units, well, it's not a proposition, it's happened, forms a network. And in our instance, it's a network of 11 ICSs and the regional office in our patch, so 12 members. And that network is an active thing and is used as a basis for sharing learning, resources, working on shared problems, and so on. And that network is supported by a development centre. And one of the fantastic things for us as the strategy unit is we've been asked to fulfil that role. So each of those members pays a subscription, which just for your information at the moment is £40,000 a year each. And then in return for that, we support the network. And what we do to support the network is we have a programme of some big analytical projects which the members select, and the outputs of which are of the format I showed you earlier, so designed to generate products that local analysts can use and take on and develop. We have an education and development offer, and we have a whole series of things to support active knowledge exchange. So the regional analytical program, we select 3 or 4 projects a year. I'm not going to bore you with the detail of these, but just if you go on to the website address I'll show you later, you can see some examples. So looking at how health service utilisation occurs in the last 2 years of life, the socioeconomic inequalities one I mentioned earlier for planned care. We've just done one recently, just designing a new way of thinking about how to classify outpatient data by attributing function to activity. So it's those quite big things, and the members choose those. We have a long list of topics and the members vote on them. That's what we do each year. We then have an educational programme which is growing fast, and Mohammed runs that. Mohammed's everywhere, as you will have realised. But that focuses on technical skills for analysts, on evidence and evaluation, on softer skills, particularly for analysts. So we've been running a leadership for analysts programme, for example, and on advancing leadership and decision quality for system leaders. And that's just a sort of quick run through of some of the sorts of things that are going on as part of that, but you'll see straight in there, introduction to R is one element of that programme that's happening at the moment. And then we also, in terms of this knowledge exchange, we've created a Midlands Analyst Network. It's got about 550 members now. We have fortnightly huddles. We bring people in from local systems, from regional, national and international, and varied numbers of participants for each session, but that seems to be really starting to have an effect of creating a Midlands analytical community. And we're just kicking off the same for evaluators and for those involved in knowledge mobilisation. So that's another part of the process. And at the outset for this, we did a whole series of things with our systems to try to develop some design principles for these decision support units and for the network. And they're all on the website for those who are interested. But I just wanted to point out that there were 2 design principles of relevance to this network. So the first was that Analytical projects undertaken by these decision support units should be fully documented and actively shared such that the analysis can be referenced and reproduced by others. So that's one fundamental principle that the members have signed up to. So the technical supporting document should contain information about the methods, the code, and the data sets used, such that others can reproduce the analysis if required. And then in design principle 12, we're suggesting that in the interests of collaboration, we recommend encouraging analysts to maximize their use of 2 languages and their associated software packages, T, SQL, and R. So we're building or starting to build R as a fundamental platform for how this Midlands decision support network will operate and how the analysts within it will collaborate with each other. It's a long-term journey. Lots of it is real. The educational program's up and running, the regional and analytical reports are being produced. Locally, the development of decision support units is happening at different pace, as always. So some places are racing ahead with it, some places are still in the early design stages, but it is a member-owned initiative. The ICSs have chosen to do this. They're putting their money in through membership subscriptions. It's not something they've been told to do by anybody else. And that feels like a really important success criteria for me, to be honest. So for those who are interested, you'll get access to these slides, but those are the web links for the strategy unit for that blog I mentioned, if anyone wants to use that to support their arguments. The Midlands Decision Support Network has its own website now, and all the detail about the educational programs and so on I mentioned, and the design principles and so on are on there. Also the reports, if anyone's interested in those topics. And then our report for advancing analytics. Now, we've produced that report for NHS England. We made a series of recommendations. They're still considering their response to those recommendations, but they've said they're happy for us to publish the report and they're interested in people's comments on it. So I really wouldn't, I know everyone's very busy and everyone's got a lot to do, but if you did have time to have a look at that report, and if you like some of the recommendations in it, things like the development week for analysts, some of the other things that are in there, send me an email saying you like it, and we'll be collating all of those comments for NHS England. Because this is one of those potential turning points, really, where the analyst community could make its voice heard by reinforcing some of the recommendations in that document, if you think that they're right. So please do that. So in summary, the actual title of my talk that Mohammed asked me to talk to is what should the NHS learn from the R community? And what have I learned about R? So the things that I see regularly and that I think the R community encapsulates really is that analysts are highly skilled people and they really care about the quality of what they do. But they need to be supported in that, and they need people around them who can help create the space for them to advance their craft. They want to do great work. They will self-organise to develop the skills to do so, and that's really important, but it's not enough. It still needs people, it still needs systems to create the space for that to happen. It needs the invitation to come from decision makers to say, we want your insights. We want you to help us identify the right questions to work on. We want to create a world that doesn't just assume that the decision makers are the only source of sensible questions. We want to support analysts to work directly alongside clinicians to address useful questions. We want to cut out all the middle people who get in the way of that. These are some of the things that we need if we're going to develop a really thriving, analytically driven NHS. We also have lots of other professionals who care about and do great analysis too. And one of the joys for me is when I see really interested clinicians who've thought a lot about the analytical questions that are useful, suddenly finding people, analysts who've got the skills to work with them on that, and a piece of work that flies out of that interaction. So finding ways to connect multidisciplinary groups together to do analysis seems critical. Analysts seem to want to share, and they've clearly got the tools to do so. This community is all about that, and that needs to be supported. Networks trump hierarchies. I don't think that what we're doing through the Midlands Decision Support Network would be anywhere near as productive if it was a top-down initiative delivered through the standard NHS hierarchy. It's working to the extent it's working at the moment because the participants have decided where they think the quality lies, who they're prepared to trust in leading their development work, who they want to work within that, and how they create the space and the environment to do it. And we need to keep supporting networks to operate in this way, horizontally organised. And then I think the other thing we should learn, my last point, Mohammed, sorry, is that the NHS can stop wasting money if it stops buying analysis from external providers who have a do once, sell lots model, and it instead turns to an NHS-led do once and share openly model. And I think that's that would be my final message to the R community. You can be part of a mission to turn the NHS to that model.
Thank you very much.
Thank you, Mohammed.
Yes, thank you, Peter. Thank you so much for bearing with the tech as well. If people have got questions or comments, do put them in the chat, but I'm going to swiftly move on, if I may, please.
I'll press stop share.
Yes, if you can stop sharing. And if I can ask Natalia, please, to perhaps start sharing, and then we will swiftly move on. So Natalia, thank you so much for agreeing to speak at our conference. I will ask you to, we do have a biography in the notes, but if you can do a brief introduction, and then I'll hand the floor to you, please.
Sure, thank you very much, Mohammed, and welcome everyone. Can I just check if you can all see my screen okay?
Yeah, we can hear you and see you. Thanks very much, Nat.
Okay, great. That's surprisingly smooth for a Zoom conference so far, so fingers crossed it will stay like this. So hi everyone, my name is Natalia Domagala, and I currently work as the head of data ethics at the Central Digital and Data Office, which is a part of the Cabinet Office here in the UK. And I will talk about data ethics and various methods for implementing data ethics within an organization. So I suppose my presentation will be a little bit more bigger picture focused than some of the previous speakers, partially because I look at data ethics more generally rather than data ethics in the health sector more specifically. So let's start with what data ethics actually is. So in general, data ethics is a branch of applied ethics that studies and evaluates moral problems. And this is all to describe the value judgments related to data, algorithms, and corresponding practices. And the goal of that is to formulate and support various morally good solutions. And in a more simple terms, the overarching aim of data ethics is to promote responsible and sustainable use of data for the benefit of people and society. And it's also to ensure that any knowledge obtained through data is not used against the legitimate interests of any individuals, groups, communities. And again, data ethics helps identify and promote standards, values, and responsibilities that allow us to judge whether any decisions made with data, any actions that this data motivates, are appropriate. And in terms of how data ethics works out in practice, I think it's really, really crucial to stress that in the digital age that we live in, we all need to understand that data ethics is not optional. This isn't something that we're doing because it's an extra, it's something added to our core work. But actually, when we're looking at the stakes and when we're looking at the the current landscape that we all work and live in, we need to understand that data ethics is an absolute must. And any project related to data analytics or digital in any way needs to have those data ethics considerations embedded from the very beginning. So I just wanted to stress this point, and I'm sure you all agree with me. But there are also various benefits to data ethics that go beyond this this moral obligation of data ethics as the right thing to do. So data ethics and active data ethics policies support trustworthy and responsible innovation. They actually help with efficiency. So reduced instances of any data inaccuracies, any mistakes, or any poor standards in of data storage and use. Data ethics, if we have the right data ethics considerations from the very beginning, those instances of various inaccuracies and mistakes will not happen. So actually, data ethics policies help us be more efficient. Data ethics also helps with decision making. So those decision making processes that have data ethics embedded are the risk of any unintended consequences is lower, because we're thinking through the worst possible scenario from the very beginning, and then we work towards eliminating it further on. And there are, of course, issues around preventing reputational damage and preventing budgetary losses. So the lack of sufficient data ethics considerations can lead to high-profile projects being shut down. And this happened in the private sector, for example. There, that of course leads to losing a lot of money and time. So if data ethics measures need to be applied retrospectively. So the lesson here is apply data ethics considerations through the very beginning, through the entire project from the very beginning, no matter what is it exactly that you do. So I hope that's all clear now. In terms of operationalizing data ethics within an organization, there are many ways of doing that. And I think it all depends on what kind of organization we work on exactly, and depends on the sector, depends on the structure. But based on the number of studies and also my own research on data ethics, I came up with 4 following functions that this data ethics team or data ethics function within an organization should have. So first, this data ethics body within an organization should provide means for negotiation and value judgment related to various ethical challenges in data and technology. So it should be a space for research, it should be a space for multidisciplinary conversations, for involving external and internal expertise, and having this dialogue related to various data ethics dilemmas. Secondly, this data ethics team or data ethics function should evaluate and propose potential solutions to ethical dilemmas. So this could mean strategic help, on the ground advice to teams. This could mean helping analysts and data scientists grapple with various ethical issues in practical terms. Then the third one is that this centralized data ethics function should establish a set of ethical principles that apply across the entire organization, and it should provide support in terms of their implementation in specific contexts. So any hands-on assistance on how we could take those high-level ethical principles that many organizations actually have these days, and how we could help analysts and data scientists use them in practice. And finally, this data ethics function should determine the types of accountability frameworks and oversight needed for any data ethics measures, and it should also set them up. So it could be things like having a chief data ethics officer, having a data ethics board, having and setting up any external data ethics oversight. And data ethics skills, again, this is a relatively new area, which has been fairly underdeveloped in the public sector, but we've been working on this, and I will tell you more about the process that we've been through to establish those data ethics skills within the government. But I think it's a really crucial element of implementing any data ethics initiatives. And In the UK, we developed a data ethics role for the Digital Data and Technology Professional Capability Framework, which I'm sure most of you know already, but essentially this DDAT for short, as we call it, the DDAT Capability Framework, improves consistency across all the data, digital and technology positions in the government. And it sets out a common language to describe roles and responsibilities. It defines the skills needed for each of those roles. And it helps facilitate recruitment, government transformation, personal development for people working in data, digital, and technology. And it also helps us identify gaps in the wider public sector skills. And although there are various very well established professions in the DDAT capability framework, we've noticed that there has been a lack of very well defined data ethics component of those communities and professions. And because of that, we made a commitment in the National Data Strategy last year in September 2020. We've committed to building lasting capacity for ethical data use, and we then developed that commitment into an action to add the data ethics focused role to this digital data and technology capability framework. So in order to develop that, the team that I led conducted a set of research exercises. So we surveyed 50 data and AI ethics practitioners from all sectors. The survey was anonymous. It was shared openly online, so anyone could participate. And the survey had skills from the DDAT data job family, and it also had additional skills that were focused on data ethics more specifically. And we also had workshops with external data ethics practitioners. So we've invited some people from the private sector where data and AI ethics as a profession has been more established. And we had a deep dive into what kind of skills are needed to work in data ethics, how those skills are different from data science skills, and what kind of roles and responsibilities should exist in terms of data ethics within an organization. And this is what we came up with, but I'd like to share a few high-level observations as well. So in terms of how data ethics skills differ from data science skills, one of the main distinctions that we found for this research process was that data science is about knowing what you could do, whereas data ethics is about knowing what you should do. And what this means is that data ethics skills are focused on understanding the society and broader socioeconomic impacts of technologies, understanding norms that those technologies help create and shape, as opposed to data science, which is focused more on specific project delivery aspects and technological capabilities rather than their social implications. So we also found distinctions like data science is gathering and drawing conclusions from data, whereas data ethics is making sure those conclusions and the methods for collecting them are moral. And all the responses from the survey that we had and also findings from the workshop really stressed that data ethics is a big picture discipline that needs to include a holistic view of the data lifecycle and risks and harms introduced at each phase of this lifecycle. So based on all this research, we developed this summary of what is it that you'll actually do as a data ethicist. So first, provide research and expertise on data ethics and act as a champion and change agent. Second, enable and empower others to implement data ethics best practice in their work. And finally, communicate effectively to explain and raise awareness of data ethics and also listen, convene, advise, and mediate between various parts of the organization. And here you can see a list of data ethics skills. So skills identified for our research process were then refined to comply with internal DDAT capability standards. They were harmonized with existing skills of the existing skills catalog, and that was all to avoid that duplication and encourage reuse of the skills that we already had in there. And this list that you can see here is the final skills that made it to the data ethicist role. So communication skills, which is all about communicating effectively across organizational and technical boundaries. knowing how to make complex and technical information simple and accessible to non-technical audiences, advocating on behalf of the team to create trust and accountability. Then skills around product development, for example, really important when developing frameworks, guides, or other resources for data ethics practitioners. So it's all about knowing how to develop those tools, knowing how to manage projects that require development of those tools. Then applied knowledge of social sciences. This one was really, really important, one of the top skills in the survey. And it was all about being a critical thinker with a social science or humanities background, being able to operationalize and implement the wealth of this theoretical knowledge from social sciences, to use it to inform data projects, products, and policies, and also to evaluate various assumptions made in those data science projects. So really key. And empathy and inclusivity, which is perhaps slightly unusual as a skill that you would see in a data-related skills framework. But in this case, it's all about having an inclusive approach to consensus building, ability to incorporate inspired views of underrepresented groups in evolving products and policy work. So it's about having a thorough understanding of social issues, understanding of types of bias and discrimination that different groups can face, and being able to use this knowledge to inform data ethics work in practice. And then we have slightly more traditional skills like stakeholder relationship management, really important when working across all those organizational and technical boundaries. And ethics and privacy, which is all about knowing the existing data ethics policies and tools within the public sector and beyond. Problem solving, again, really self-explanatory. Analysis and synthesis, so this is all about being able to draw together, analyze, and critically evaluate information from various sources, and knowing how to synthesize that and communicate that to colleagues. Bridging the gap between technical and non-technical, I think this one is really key, all about translating technical concepts related to software engineering, delivery management, service management, data science, to audiences, to policy audiences, for example. And this requires a good understanding of how technology and data products are built. So anyone working in data ethics needs to be familiar with the technical jargon, and they need to have a sufficient knowledge of data to actually hold meaningful conversations with data science experts on issues such as minimizing bias in data, data gathering, data collection, data use and reuse, etc. And this is all about effectively supporting data scientists and engineers, but also being able to translate all the work that they do to policy audiences and general public. And finally, facilitating decisions and risk, which is all about making effective decisions, explaining how those decisions have been reached, and having the ability to understand technical complexity and risks. So that's it in terms of data ethics at the organizational level. And now I'd like to take a bit of a closer look at one of the tools that we developed at the Central Digital and Data Office to support our data scientists and data analysts and anyone working with data to make sure that they implement all those data ethics policies and initiatives. So the tool that I'd like to talk about is called the Data Ethics Framework. And the purpose of the framework is to guide appropriate and responsible data use in government and the wider public sector. And it helps public servants understand ethical considerations, address those ethical considerations in their project, and it also encourages responsible innovation. And it was launched in 2016. Back then, it was one of the first documents of its kind, and it very much formed the basis of our future work on data ethics. And it's aimed at anyone working directly or indirectly with data in the public sector. So this includes data practitioners, data policymakers, operational staff, essentially anyone working with data and helping to produce data-informed insights. And the way the frameworks operates is that multidisciplinary teams should go through it together throughout the entire process of planning, implementing, and evaluating a new project. And they should also revisit the framework regularly as their work evolves. So it's not something that you would sit down and do in one go, but rather the framework is supposed to provide some help and for various conversations that people would have within their teams in terms of addressing those ethical dilemmas, as they as we all know, they can be very, very complex. So this is how it works. And just a quick note that we refreshed the framework in 2020. So first it was, as I mentioned, it was developed in 2016, then it was refreshed in 2018, and we refreshed it in 2020 again. And I'm stressing that because we need to understand that technology and data is a really fast moving field, and government guidance needs to reflect that. So so any data ethics work isn't set in stone. This is something that we need to constantly revisit, reevaluate, and refresh to make sure that it actually, those kind of tools continue to meet those user needs. And this is how the framework looks now. This is the shorter version, and as you can see here, we've got overarching principles that should apply to every stage of the work with data. So that's transparency, accountability, and fairness. And these are non-negotiable. They apply across the entire process, the entire cycle of any data work. And then on the right here, you can see that we've got a set of specific actions that have been reordered to reflect the project cycle. And this is all to increase the effectiveness of the framework and to make it easier for users to follow. So now I will very quickly talk you through those specific actions. So firstly, when starting any public sector data project, you must have a very clear articulation of its purpose. So this includes having clarity on what public benefits the project is actually trying to achieve, and what are the needs of the people who will be using this service, or will be most affected by whatever it is that you are producing in this project. Then involve diverse expertise. So working in diverse multidisciplinary teams with wide-ranging skill sets contributes to the success of any data or tech project, especially in the public sector. So if you don't have those sufficient skills or experience in your team, you should involve others from the outside, from the wider network, maybe external expertise as well, to find the right set of people who will be able to address this challenge that you're working on. Then, of course, you must have an understanding of the relevant laws and codes of practices that relate to the use of data. And when in doubt, you must consult relevant experts. And we are stressing this in the data ethics framework as well, because I think it's really crucial with this kind of ethical guidance to understand that they're not here to substitute the law, but actually they're here to help us navigate some of this gray area that we have between what's legal and what's acceptable, perhaps. And this one is all about data. So insights from any new technologies and data are only as good as the quality of data and as practices that are used to create those insights. So what this means is that you absolutely must ensure that any data that you're using for the project is accurate, representative, proportionally used, that's of good quality, and that you're able to explain limitations of this data and again mitigate any potential issues that could arise. And finally, it is essential that there is a plan to continuously evaluate if insights from data are used responsibly. And this means that both development and implementation teams need to understand how findings and data models should be used and how they should be monitored with a robust evaluation plan and effective accountability mechanisms in place. And very quickly, a few use cases of the framework. So it has been used to evaluate ethical considerations of data science and data policy projects. So one of the prominent examples that we have was with the Essex County Council. That was back in 2016 with the first version of the framework. Essentially, they used it to facilitate their stakeholder engagement and analyze ethical issues around the prototypes that they were building. Then the second case is when the framework has been used to assess ethical standards of project partners and suppliers. And we worked with a Crown Commercial Service on making sure that that any suppliers bidding to join their system that they use to procure artificial intelligence product are actually complying with the data ethics framework and are meeting ethical dimensions of the tender as well. So data ethics framework was a tool that they had to demonstrate that they are using. And finally, the data ethics framework has been used across the public sector, and it has given teams and departments a template for the development of their own guidelines. And it was a starting point for many of government guides, such as the Office for AI Procurement Guidelines, for example, and the very first version of the Code of Conduct for Data-Driven Technology produced by the Department for Health and Social Care. So in terms of implementing the data ethics framework, we are currently working to embed it with as many existing processes in the public sector as possible. Also working on developing training on data ethics skills and the framework more specifically. There are activities around sharing knowledge within those ethics communities of practice that we are currently working to set up. And finally, promoting the framework and talking to people around the public sector and saying that if there is anything that they would like to do with data ethics, the framework is a good place to start. So anyone can take it and reuse it, adapt it, and modify it to make sure that it works for their specific needs and the needs of their team. And that's it from me today. So
Natalie, that's lovely. Thank you so much indeed for sharing data ethics with us, and also expanding our thinking on some of the challenges that modern data science has to address. Colleagues, because we're running a little bit behind time, I'm going to call a break at this point, and we're due to come back at 11:05 for the next session. But if I can ask you to perhaps join a minute early, just so that we can get the kind of preliminaries sorted. So we'll have a break now till 11:04, and we'll start our next talk at 11:05. Thank you, everybody, and thank you all our speakers for this morning. That's been really interesting. See you soon. Bye-bye. Colin, thank you so much for joining us. Can you hear me okay?
Yeah, I can. Sorry, I couldn't unmute myself, but
No,
now
fine,
I magically
great.
can.
So Colin, if you would just introduce yourself, please, and then start your presentation. Thank you very much.
Yeah, absolutely. Okay, well, I'm going to introduce myself in a second. So I'm going to talk about the challenges and opportunities of visualizing COVID data using R. So just a little bit about me. I'm a senior research fellow at the University of Sheffield. I'm a mathematical modeler, hence the Twitter handle, which is Victim of Maths. My quote unquote normal job back in the olden days, before everything went a bit crazy, is working in alcohol policy. So looking at how different alcohol policies impact on alcohol consumption and how that changes health. And in particular, the thing that I've always been really interested in is inequality. So how policies and just trends and behaviors are different and have different impacts across different groups in the population. So, you know, when things change, does that make inequalities wider or narrower? So that's sort of the angle that I've come at a lot of the COVID analysis from. And I really, really like graphs and making graphs and looking at other people's graphs. And I have an unhealthy fascination with Twitter. So I've always really enjoyed posting graphs on Twitter. And back in the early days of the pandemic, I swore that I felt like other people had it covered. And I swore I was definitely not going to go anywhere near graphing COVID data. And then someone specifically asked me to do some analysis of inequalities in COVID case rates, and I couldn't see anyone else had done it, and so I did it, and then I fell off the wagon, and it's been a journey since then. So a little bit of, you know, this is an R conference, so a little bit about my kind of history with R. I started using R back in 2017, specifically for the purpose of making graphs, and sort of more specifically for the purposes of making this graph. The reference is there in the bottom right if anyone's really enthusiastic about learning more about this. I'm not going to make any claims that this is a beautiful graph, right? This is the first thing I ever did in R, and I've hopefully progressed a little bit since then. But back then, my process for working in R looked like this, right? So I'd find some data from somewhere, I'd tidy it up and process it in either Excel or Stata, which is the things that I was familiar with. And then I'd import the sort of the tidy CSV file into R and then do the visualization. And since then, you know, I've become a better person. I'm all about the R now, but you know, but that's how I used to work. And that's kind of how I, you know, a lot of people say, oh, everyone says we should get into R, but I don't really know what to do. And that's kind of, I think, a good gateway into it. And then I just want to get on my little soapbox here. Back in 2019, so, you know, coincidentally before COVID started, I made this decision that I was going to share the code behind all of the graphs and analysis that I posted on Twitter. So I post quite a lot of, you know, just random graphs of stuff that I find interesting. And I decided that I was going to share all of the code behind that, right? And I have no regrets, right? This was a totally good decision. And I think you should all make the same decision. And why? Well, when you know someone else is watching, you write better code, right? You comment it, you set things out more neatly. You maybe do slightly less naughty, hacky things, although naughty, hacky things can be okay. Being transparent can build trust, right? It's much, people can't call me out and say, oh, well, you know, I think you've done your analysis wrong. If I've published the code, they have to tell me how I've done it wrong because I've been open about it. And so that means that people believe in what you're saying more. You'll have to learn new things, right? So because you know that other people are looking, you have to work out how to, and what I want to do is I want to publish code that anyone can run, you know, on a new computer that will produce the same outputs as I'm publishing. So I have to, you know, I've had to learn how to download data and do all sorts of data cleaning stuff in R that I never knew before. Most people are really nice. I mean, there are always some weirdos out there on the internet, but most people are really helpful, and especially R people, right? You know, they're really nice, and people will help you solve problems that you've got and, you know, improve your code for you even without being asked. It's great. and other people will learn stuff from it. I think this is something a lot of people are really reticent about. They feel like, oh, no one will appreciate my code because it's just stupid and simple. But other people will learn stuff from your code, right? That's how I learned everything I know about R. I learned from just looking at other people's code and reading Stack Overflow. And, you know, if you're struggling with it, just think, would my past self have benefited from looking at my code? And, you know, probably they would. So share it. And also people will take the stuff that you publish and they'll remix it and do interesting new stuff. I've had loads of amazing messages from people who have said, oh, you know, thanks for publishing a code. Here's a cool thing that I did that's based on it. And it's amazing. So more of that, right? And there's two arguments that people give against sharing code commonly. And one of them is that their code is horrible and rubbish and they don't want people seeing it. And I'm an extreme pragmatist, I think, right? The ugly code that works is infinitely better than the beautiful, sexy, elegant code that either doesn't work or never gets written because, oh, it's really hard work to write nice code. So, you know, if your code works, it's good code in my book, and worth sharing. And the other argument is people saying, oh, well, you're working with open data. All the data I work with is kind of closed data. So there's no point in me sharing my code. But while I think there might be some circumstances where it's a bad idea to share the code, I think in most cases, you should still publish the code openly, even if the data itself isn't open, because there'll be other people who work with the same data who could appreciate your code. And you can still learn from code that you can't yourself run, right? You can still take, you know, the way that people have done stuff, especially if it's well commented and well documented. And your future self will really appreciate it, right? Because when you want to do something again, you can come back and look at it and you'll have documented it nicely and put it on the internet. So you can find it more easily than scrubbing around on your hard drive trying to remember where you saved that file. Okay, get off my soapbox, talk about COVID and data. So these have been amazing, crazy times for all sorts of reasons, but they've been fascinating times for weird data nerds like me, because there's just an overwhelming amount of data that's been published in relation to COVID. So we've got the government dashboard, which is fabulous and has all sorts of amazing data about all kinds of different stuff. PHE, now UK Health Security Agency, published reports full of extra bonus data. The NHS published data on stuff going on in hospitals and vaccinations. The devolved administrations publish their own, sometimes the same, sometimes different data. Public Health Scotland, Public Health Wales, same in Northern Ireland. The ONS publish all sorts of exciting and interesting stuff, right? And then the other devolved nations, NISRA and National Records of Scotland, also publish mortality-related COVID statistics and some other stuff. And that's before even before you get onto the like data aggregator sites, people like Our World in Data, who sort of pull data from all sorts of different sources, or before you get onto international data. So there's all kinds of data, right? I feel like a kid in a sweet shop. It's just too exciting. There's too much stuff. And it is a land of opportunity. And I think open data has been one of the few things that's really benefited from the pandemic. Suddenly, we've got a lot more data being published, and it's being published faster. And that's great. Maybe less great for the people who have to work really hard to publish it. But for me as a consumer, it's great. And there's been incredible progress been made in terms of linking data. Stuff like the Open Safely project is just, phenomenal. The amount of the sort of kind of the barriers that have been broken down in the last couple of years. It's amazing. And so as a result of this, doing new analysis that has never been easier, basically finding something that you don't know the answer to, and that, as far as you're aware, has, the answer isn't widely known and in the public domain, is much easier. It's much easier to think of interesting, cool, new stuff to do in relation to COVID data than it ever has before. And that's brilliant. But, when you're exploring uncharted territory, you always have to be careful. There might be dragons. So there are some examples of this, right? There was the very widely publicized spreadsheet error that led to 16,000 people just disappearing or not having appeared in the case data last year. There was a bit of controversy when PHE as they were at the time, revised their definition of a COVID death from being anyone that had died after a positive test to anyone that died only within 28 days of a positive test. And suddenly the number of COVID deaths changed, and that confused people. And then more recently, there's been a, I'm sure this hasn't passed any of you by, a big kerfuffle about vaccination status. And, Joe Rogan's podcast, one of the most widely listened to podcasts in the world, talked about this graph here on the right, which appears to show that people who have been fully vaccinated have higher case rates in older age groups than people who are unvaccinated. And obviously it turns out it's a lot more complicated than that, and that's not a sensible interpretation, but there are dragons. So let's talk a bit more about these mistakes and misinterpretations, right? In this shifting data landscape, right, the availability of data has changed constantly and continues to change, right? It's not that things have settled down now. New stuff's being published all the time, like booster vaccinations. They've just appeared in the dashboard in the last couple of weeks, for example. And that's both in terms of what data is being published, but also who's publishing it. Stuff moves around, and it's quite hard to keep track of. And also the content of that data has been changed, right? The definition of individual indicators has changed, like the deaths issue that I was just talking about. So the nature of the data has changed. There's loads of time series that have a little asterisk in them because the definition of the thing changed halfway through. And that can make things a bit tricky. And the fact that we're getting data published so quickly, which is brilliant, also means that there's more opportunity for the data to have a few little wrinkles, I'm going to euphemistically call it, right? And obviously that's bad. So there is more, it's basically there's less time to do really robust QA checks on some of the data that's being published. And I've no doubt people publishing it are trying their absolute best, but still some errors slip through the net. And so just to look at some examples of this, right? Understanding definitions is hard. So this is COVID admission rates for the 4 UK nations from the first 6 months or so of the pandemic. And you might look at this is data just pulled straight off the dashboard. You might look at this superficially and say, oh, Wales had a real problem with COVID admissions, right? That blue line there is much higher than the other 3 lines. So you might look at this and go, oh, well, there's a problem. But actually, that's a wrong interpretation, because actually Wales was using a different definition of a COVID admission. Wales at that stage was including any suspected COVID cases who were in hospital, whereas the other nations were only including people with a positive test. So unless you understand that, you risk making an incorrect inference about what's going on. But also just stuff's confusing, right? This is the problem that underlies that issue that the Joe Rogan podcast was talking about, which is that in order to estimate coverage of vaccines, you need to know how many people there are to cover. And actually, we don't really know that. And there's different sources of population estimate. So this graph here shows shows vaccine coverage by age, using 2 different estimates, right? So NIMS, which is kind of the standard dashboard use, which is the white circles, and ONS, population estimates, which are the black circles. And a couple of things here to particularly draw your attention to, right? There's a big difference in younger adults. So if we're looking at 35 to 39-year-olds, right, is it 20% of the population that's unvaccinated, or is it 34%? That's a huge difference. And that's not all of the weirdness, right? If you might notice up there that 102% of 75 to 79-year-olds have been vaccinated using ONS estimates. So that's weird and confusing, and you really need to understand the vagaries of the data in order to understand why these differences occur and why, and what they mean and what the truth might actually be. And sometimes, just to give an example of one of these wrinkles I was talking about, right? The data can just be wrong. Okay, this is something I noticed on the dashboard the other day. It was only there for a little while before it got fixed, but that's not right, right? Scotland didn't vaccinate 250,000 people in one day, having previously, not exceeded 60,000. So what can we do with all of this, right? Well, we should be cautious, okay? More cautious than usual, perhaps, and read the documentation really well, especially with when you're getting into new data. That's always true, but it's really important now. Be skeptical of stuff, right? If you find something, you find some amazing new insight, be a bit more skeptical than you might usually be, that maybe, either there's something wrong with the data or you've messed up. And be humble, right? You find something a bit weird, don't just immediately go and shout it from the rooftops. Maybe be a bit more circumspect about that, but not to the extent that you don't talk about it, right? Don't be afraid, but just be a bit humble. And that's all kind of looking at the mistake side of things. But what about the misinterpretation side of things, right? People are awful. Hell is other people, right? And whenever you put things out on the internet, there's always going to be someone who finds a way to misinterpret it. And with so much data out there, sometimes, different data giving you different perspectives on the same question. And it's easy for people to get genuinely confused. And COVID's a really polarizing topic, right? Whether we like it or not, people have strong opinions about it. And sadly, there are some people who just want to win arguments, right? They're not interested in being right, the truth. They just want to, win the fight. And, I've experienced this, right? So I made an app last year, which would make graphs of COVID mortality statistics, right? And so this particular graph here was showing deaths by date of occurrence for COVID in sort of red and for other causes in orange there. And loads of people, this was around about the time when people were talking about there being a case-demic. They were saying, oh, there's loads of cases, but no one's dying. It's all just false positive nonsense. And so some people who believe that really liked the fact that this graph here showed this kind of mirroring, right? Showed loads of many fewer other cause deaths at the same time as there were COVID deaths. And they said, oh, it's just misallocation of the deaths. But actually, that's a misunderstanding of the data. But that didn't stop people from, using this to further their own arguments. So what do we do about all of this? Well, we need to try and minimize the risk of people who are acting in good faith misinterpreting, right? So people just not getting the message. And also, I'd argue, try and head off the possibility of people who are acting in bad faith being able to misrepresent stuff that we put out there. But how, right? What do I mean? How can you do this? Well, right, so we can start with neutral presentation of data, right? It's not a thing. So don't pretend that it is, right? I don't believe that there's such a thing as neutral presentation of data. There are more or less value-laden ways of presenting data, but there isn't a way of presenting it without something, even your choice of colors carries some meaning. But we can use this to our advantage, right? People love a story. If you're going to show someone a graph and if they're going to remember it, they're going to remember it because they've read a story into that graph and it's kind of resonated with them. And so if someone's going to infer a story from any graphs that you publish, I think you might as well help them to infer what you think is the right story. Other opinions are available. This is my opinion. So what does that mean? Well, whenever you're presenting data, work out what the question is that you're trying to answer and speak to that question and tell that story, right? So when people ask me, oh, can I have some advice about my graphs? The thing I spend most time doing is going, what is the story you want to tell here? What are you trying to achieve with this? And so just a few quick examples, right? This is a heat map showing the male to female case ratio by age, right? So green is more female cases and purple is more male cases. And there's a load of different stories you could tell in this graph, but I'm choosing to tell the one about this big green blob on the right-hand side, right? Cases in 20 to 49-year-olds are very female dominated, and that hasn't totally disappeared yet, right? So I'm telling the story here by giving a very leading title to the plot. And that's what I tend to do for these kind of explanatory graphics. So another example here, COVID admissions in London have started to fall, but also you really lean into that here. So this is looking at regional hospital admission rates, and I'm not giving all of the regions the same prominence, right? I'm telling a story about London and how it compares or is different to the other regions. So I've just grayed out all the other regions and I'm just picking out the bit of the story that I really want to tell. And that doesn't apply for everything, right? There's also exploratory graphics where you're just kind of presenting stuff and letting people pick their own story. So this is a timeline, like a heat map showing COVID case rates for every local authority in the UK. And there's people will find their own little stories. They'll find their own local authority in the graph, and assuming they can zoom in far enough. And another example, sometimes you get things that are a little bit in the middle, right? So sometimes when I publish versions of this map of local COVID case rates, I'll have a story, cases are really high over here. But sometimes the story is just, find your own story, find yourself, and that's okay. And then you can also do things to try and head off that misinterpretation, right? So this is the more recent version of that graph that people used to misrepresent. And I added this big old disclaimer up here trying to say, it's all about underreporting. So don't do that, disingenuous people. So just to quickly summarize all of that, right? When you're creating graphics, I think you should work out what the story is that you want to tell and really lean into that story, right? Try and tell that story well. Do what you can to try and head off misrepresentation and react to misrepresentation when it happens, if you can. And being transparent helps with that, right? It's harder to misrepresent you when you've been very clear about exactly what you've done. And finally, share your code. So in the interest of sharing my code, there's my GitHub repo. If anyone has any questions, feel free to email me or hit me up on Twitter. Thank you.
Colin, thank you so much indeed. Thank you also for keeping to time and giving us a really lively review of graphics and COVID. Some important messages there, and quite a few people have benefited from your sharing and have already mentioned how much they've benefited from the code you've shared. So thank you so much. I am going to move on now to our next speakers, Madeleine, Whelan and Yuill, please. So if you can tee up your sessions, thank you for that. And I will hand over the mic to you and ask you to please introduce yourselves. So thanks very much.
Hi, can you see the screen now?
We can see you, Madeleine, but not your slides. So when you're sharing your PowerPoint, sometimes you can say which monitor you want it to go to.
Yeah. Is that better?
No, not yet, I'm afraid.
Mm.
Is it just me? Can anybody else see? Just in case it's just a user problem on my side. No, Will is also nodding in the horizontal plane. Do
you want me to try sharing, Maddie?
Yeah, maybe. Sorry.
Right.
Yeah, okay.
That seems better. Thanks, Will. Sorry, I don't know what's going on with mine. Okay, so we can start then. So my name's Maddie, and myself and Will are just going to chat through the modelling that we did relating to COVID-19 in our local area. So myself and Will both work for Hertfordshire County Council in the public health team as part of the evidence and intelligence kind of area of that team. Next slide, Will. So to start with, kind of why we thought we needed a local model. So I'm sure kind of everyone who's worked in the last couple of years in public health knows at the beginning of the COVID-19 pandemic, there was a lot of uncertainty and there was a lot of rapidly changing information. And the modelling that did start to come out was kind of at a national level and not much at a kind of local level. And locally, what we were seeing didn't always kind of match the national picture or the literature that was coming out. And kind of because of that, we started getting a lot of requests from different partner organisations in our area, wanting a very large variety of things. And we wanted to kind of be able to model all parts of our system, as well as that kind of have a single truth across the system that everyone was kind of working off. So we're all kind of on the same page. Next slide. And so this is kind of the final model that we came up with. Obviously, it's like relatively complicated, but it was quite an iterative process to get there. So on the left-hand side, we had the SEER model to generate our number of cases, which I'll go through a bit more in a minute. And then on the right-hand side, we have our patient flow model. So as you can see, we kind of tried to model all parts of our system, going from kind of urgent primary care through to secondary care, and then community care and post-discharge services as well. So we kind of modelled, right through from people becoming symptomatic to calling 111 to the different kind of beds they might be admitted to, the different types of treatment that they might get, and then, like I said before, through to kind of different discharge pathways that our hospital had and the kind of post-discharge care that they would get in those beds. So this is kind of our SEER model that we were using. I guess just briefly for people that aren't really familiar with SEER models, so I'll just briefly explain it. The SEER model is a kind of compartmental model. So people move through the model based on their disease status, and people can only be in kind of one compartment at a time. So the four kind of basic components is you have your susceptible, you're exposed, you're infected, and you're removed. So in your susceptible, you have the susceptible population for the disease, and people move from the susceptible to the exposed based on kind of the infection rate, and they'll stay in the exposed until they're infectious. So people in the exposed are not yet infecting other people. People in the infected can then infect people in the exposed, can infect people in the susceptible population, and then they'll move from infected to removed based on kind of the recovery rate, and the people in removed can be both immune or they could also be dead. So that's kind of the basics of the SEER model. And then kind of how we implemented the SEER model into our model. If you go to the next slide, Will. So we, sorry, you can see here the beginning of our SEER model, which we first did in Excel, and at the top you can see some of the parameters that we used. So we kind of had a 5-day lag in the effects of the interventions, or around a 5-day lag, as well as a 5-day infectious period. And we found it quite useful in the beginning to do it in Excel, just so we could visualize how the variables kind of related to each other. But of course, this gave us issues with scalability and being unable to kind of run the SEER model for as long as we may have liked. Oh yeah, I just forgot quickly, in terms of generating our kind of cases to get our initial kind of infections, we upweighted our cases by the percentage of cases that were undiagnosed, and this figure we kind of took from the literature. And then in terms of getting our cases from the number of infections, we downweighted the infections to get our cases. So once we had done this in Excel, we then realized we kind of needed to move it into R. And you can see a picture, which we probably can't see very much of our SEER model in R, but just as an example. So kind of moving the SEER into R really allowed us to kind of increase the complexity that we could do, and obviously got rid of the issues with scalability. So once we moved it into R, we were able to add in different cohorts and also add in kind of the effects of vaccine, which you would have seen on the previous slide in that SEER model. So that was kind of our SEER model. So then on to kind of the more patient flow part of the model. It was quite a complex process as well, agreeing on the patient flow model. We worked with a lot of partners across our system. So we had kind of right from acute trust. So we've got 2 main acute trusts in our area. And, they were kind of interested in the capacity of the hospital, A&E attendances. We had 3 CCGs, which were quite interested in kind of virtual wards and long COVID. to community trust, obviously looking at kind of the other end after discharge, looking at rehab beds. And then within the council, we had adult care services who kind of work with packages of care and people coming out of hospital, as well as the coroner's service that wanted mortuary capacity. And a bit down the track, we also started modelling some stuff for the contact tracing. Once that kind of came in-house and we were contact tracing people locally, they were wanting to know the case volume, so they would know how many people they might need to be calling on any given day. So they were kind of the main kind of people that we were working with in terms of making the flow model. So in terms of actually implementing the flow model, we had to use a lot of data that we got mostly from our partner organisations, but also some from the literature. So we created assumptions for each indicator, and then using the patient flow mapping combined with the assumptions about what percentage of patients would take each route through the flow model, as well as a kind of length of stay in each different area of the flow model. This allowed us to kind of estimate the number of people in each parts of the system at any given time. And so we, again, first did it in Excel, and kind of the reason we first did it in Excel is we wanted to do it very rapidly, and that's the picture at the top. At the time, our team had only kind of just started moving everything onto R, and so the Excel kind of allowed us to create it very rapidly, and as well as that, kind of visualize the movement of people between the different areas of the model. And as well as that, the partner organisations we were working with aren't very familiar with R, and in creating this model, we were able to kind of send it out to them, and they were able to select the scenario they wanted to run through the model, and also the different populations they were wanting to model for. And they found that quite helpful. Of course, the issue with doing it is in Excel, as we really quickly came to the limit of Excel, we were having difficulty running the model for as long as we wanted to. Our length of stay indicators were using chi-square distributions in Excel, so we just couldn't continue in Excel any longer, and we wanted to add more complexity to the model that just wouldn't have been possible in Excel. So at this point, we moved the flow model onto R. And on this slide, there's just a few examples of how we kind of coded the flow model in R. So we imported the parameters file, which had all the assumptions in it, into R. And the first top example you can see there, admissions to critical care, or direct admissions to critical care, is kind of the easiest coding example of the flow model, where the indicator is very simple to kind of create in R. We're just doing a percentage of all the people that were admitted. So that's relatively straightforward by date, because our parameters could change depending on the date as treatments changed, and obviously as the pandemic kind of changed. And then the second kind of block of R code there is looking at the indicators that required a chi-square distribution. So we wrote a function in R for a chi-square distribution and applied that function to the indicators, which were based off length of stay. So you can see two there. There's one that's for people in critical care who die, and one for people who survive, because we had a different length of stay for people who were dying and people who were surviving. And then the third little block of R code there is just showing an example of the code we used when we were wanting to lag some of the columns. So for the deaths, for example, people aren't going to die as soon as they get infected. And so in this case, that one was lagged by 10 days. So that's just another example there. So next slide. So another component of kind of building our model was deciding on the scenarios and generating the scenarios that we were going to run through the model. And this was kind of like quite a process of trial and error, and kind of changed throughout the pandemic based on the kind of information and the literature that was coming out. But this is just kind of shows one example of how we did it at one point in time. you can see on the kind of top left graph is a graph that was put out by Imperial. And this graph kind of showed the percentage reduction in RT for different interventions. So you can see, you know, the effect of lockdown was an over 75% reduction in RT. So we kind of looked at this graph, and then based off an initial RT of 4, we kind of calculated the actual RT reduction of these different interventions. And then when the government announced, you know, their plans to lift lockdown, we then applied that to our scenarios. So we kind of, you know, if the government said that they were going to open a certain year group of schools, and we knew the amount that closing schools had on reducing the RT, we would kind of say, oh, well, they're going to open schools by 10%. So what will that increase be? So that's kind of one of the ways we generated some of our scenarios. And then next slide, Will. In terms of actually implementing those scenarios, it was a relatively similar process in both kind of R and Excel, although a lot easier in R. So we had kind of a table with our scenarios. When we're in Excel, an individual could select from the drop down which scenario they wanted to run. But it was quite a time-consuming process, particularly if we wanted to visualize kind of the output of multiple different scenarios at one point in time. We would have to copy across the output of the model for each scenario and then kind of create the graphs, which is not ideal. Whereas when we were in R, we would just import the sheet and the model would loop through all the scenarios running the model. And then we could obviously also create the visualizations in R, and we use the actual, we could also in R use the actual vaccination numbers. So again, adding that like increased complexity that wasn't possible in Excel. So at this point, we kind of had our model running and it was like producing outputs and everything was going quite well. But it was still the model in R was quite a time consuming to run. It was taking about between like 15 and 20 minutes to run the model. And that was because we had, we would be running a lot of different scenarios at once, but also running multiple different sets of assumptions at once. We had a different set of assumptions for our over 60s and our under 60s. So we were kind of running a lot of different scenarios. So we had some help in trying to optimize our model and see what we could do to kind of get it running better and quicker. So the first thing was kind of using the ProfVis package to identify where in the model any bottlenecks might be occurring. And this kind of identified that within our chi-square function, the kind of nested loops in there was taking up a large majority of the time to run the model. So just by replacing those kind of nested loops with the outer function really helped in terms of the processing time. And the second kind of optimization thing that was done was replacing the for loops surrounding the patient model flow function and using the FIR package, which kind of allowed the parallel processing to occur. And again, by making these kind of two changes, we decreased our model running time from around that 17-minute mark to like less than 20 seconds. So it was a huge difference in terms of processing and optimizing. So that was kind of how we developed our model. And then obviously we had the other aspect of the model was really done to kind of produce outputs and visualizations that could then be used. So this is just an example of a few different visualizations we've created at different points in time. So you can kind of see in the top left is a visualization looking at the number of cases, and we have the actuals in that kind of light brown color, and then some different scenarios we were predicting in kind of November. And then below it, you can see the same scenarios run in kind of January time and how our predictions had kind of matched with what had actually happened, which was relatively closely. And then on the other side, we have another, visualization of admissions that we were modeling, and some of the scenarios we'd been running for that. And the bottom right has another example of something different that we did when we were looking at the return to mobility. So how infections would look depending on the percentage return of mobility. And so that's, yeah, kind of another thing that we looked at. So now I'm going to hand over to Will, who's just going to chat a bit more about kind of how the information was used and then where we've gone to from here.
Yeah. So as Maddie said, we had a range of different audiences on the kind of more operational side, but we also had a few different audiences on the strategic side as well. So we used RStudio Connect to make an automated markdown report, which refreshed every day. So it brought in the latest kind of actual service data and paired it up with the model. So, updated things like vaccination numbers and things. And that allowed both operational and strategic users to actually kind of use it for quite rapid decision making. So, for instance, the strategic coordination group used it on their agenda to act as a little bit of an early warning system. So under this scenario, in 2 weeks' time, you might breach on this particular part of the system, and how can we adjust what we're doing to try and make that not happen, or limit the impact if it does. It was used for kind of operational groups to do things like, well, if we try to redirect patients around bottlenecks, what effect might that have? And for all of those, it was quite important to have clear messaging to reduce the risk of people misinterpreting or misusing the modelling, because these are scenarios, not necessarily predictions of what is going to happen, but more a kind of case of under this set of assumptions, this is what might happen. And presenting the actuals along with the model was really useful to keep it grounded. So going forward, we're starting to do modelling on quite a lot of other topics as well, such as the management of heart failure patients in virtual hospitals and winter pressures. But we're trying to adopt a little bit more kind of rigorous methodology from what we've learned over the course of COVID. So system dynamics modelling is kind of the robust version of what we've done. So similar to the model that Maddie went through, system dynamics has things called stocks and flows, kind of as we showed before, but it also allows much more detailed modelling of things like causal feedback loops and delays, and it comes with a proper modelling framework rather than putting things together, and that kind of would allow us to do things like modify the number of attendances at A&E based on how busy A&E was, on the assumption that people don't want to wait for 8-10 hours, etc. And typically system dynamics modelling is done in programs such as Vensim and Stella, which are quite expensive pieces of software and also very specialist. But you can relatively easily do it in R. I say relatively, possibly because I don't know Vensim or Stella terribly well. So in comparison, it's not too hard. So you can use things like the dsolve package and diagram R to both create the models and visualize them. There's a very good book called System Dynamics Modeling with R that a professor in Ireland called Jim Duggan has done, and all of his code is on GitHub and is very accessible. So if you're interested in doing system dynamics modeling, definitely recommend that.
Will, 1 more minute, please?
Yep.
Thank you.
And well, finally, we started doing some work on how we can build system dynamics modelings with Shiny apps. So it's an example of the model that we built for COVID, but in a system dynamics form, but interactive, and that allows a lot more interactivity than our current model, and I think would make it a lot easier to build models which require feedback from partners in the system, because we can quite easily kind of change things on the fly. And I'll stop there, conscious of time.
Great, thank you, Will and Madeleine. There's been lots of interesting chat in there while you've been speaking. Unfortunately, we are running short of time, so I will have to move us on, if I may. But colleagues are able to contact you. I know you're very active on Slack, and also there's no doubt a follow-up, a way to contact you. But if people are not sure, then ask the central team and we'll aid an introduction. So if I can ask Colin Fay, please, to tee up. Thank you, Colin.
Hello.
And I will mute myself. Colin, do introduce yourself and take the floor.
Okay, I'll start by sharing my screen. So it should be good. Okay, so hello everyone. So my name is Colin. Thank you for having me today. So I want to have a small talk about accessibility. So this talk is called Let's Talk About Accessibility. Okay, so just a little bit about myself. So I work at a company called ThinkR. We are a French company focused on data science and R. I do a lot of open source work. I'm the lead developer of the Golem project, which is a framework for Shiny application, and I'm the main author of a book called Engineering Production Grade Shiny Apps. So you can find me on internet. So I'm protective on Twitter. So if ever you want to reach out, feel free to send me a direct message on Twitter. I'll be happy to chat with you. So just a quick presentation of ThinkR. So we are a data science engineering company focused on R. We do training, software engineering, we do R in production, and we do some consulting. So just before I start this talk, just a little bit disclaimer. So first of all, I'm going to talk about accessibility, but I'm not an expert on that subject. And on top of that, I only have 15 minutes to talk about this, and I'm going to show some tools to help you work on accessibility, but there is no tool that can ever replace an audit by a real person on accessibility. So why am I doing this presentation if I'm no expert and I have a very short time? So basically, accessibility is something people learn in web development. So it's web development 101. So a lot of people learn about this when they are doing web development, but in the R world, you'll start we start with statistics, and then we move to sharing our contents on the internet, and then we move to building Shiny applications. So we don't talk enough, we don't learn enough about accessibility in the R world, and we've seen a lot of presentation today about building models and sharing the results on the internet and sharing to the world our results. But this is something very important when we are sharing content and tools. So it's very important to think about accessibility. So when I say it's web development 101, so this is, for example, the curriculum on Free Code Camp, so which is an online platform for learning web development. So if you do the very first course about web development, so responsive web design, you are going to learn basic HTML, basic CSS design, and the fourth course is apply accessibility. So this is something very important when you are building tools that are to be shared on the web. And yeah, this is like web development 101. We talk a lot about this in the web development world, but not enough in the R world. So hence this talk today. But the first question is, what is accessibility? So accessibility is something which is very prominent in the web development world. So this is, I'm going to read two quotes about what is accessibility. So when you are building the web, you are building tools for the web, this is something that is designed to work for all people, whatever the hardware, software, language, location, and ability. So the important thing here is ability. When the web meets this goal, it is accessible to people with a diverse range of hearing, movement, sight, and cognitive ability. Another quote from this website is, there is an important impact of disability on the web, because if if a tool is not accessible to people with some disabilities, they can't use your tool. So for example, if you are building a Shiny app, or if you are building a report or a web page or something very simple to share your results, and it's not fully accessible, people are not going to be, some people in the world are not going to be able to have access to it. And when it comes to things like results about COVID or models or things like that, which are very important for the public, it is very important to think about how to make these content available. So just to summarize, what is accessibility? So thinking about accessibility is thinking about how to make tools and content that everyone can use and everyone can access, whatever your location, ability, or wherever you are in the world, you can access and read the content. It's even more important in things like public health and sectors like that. So I just have 15 minutes, so I'm gonna show you some example, just for you to start thinking about things. So accessibility in practice, what can you think about when you think about accessibility? Something very simple is color choices, because as you might know, some people are colorblind. So colorblindness affects around 8% of men and 1 out of 200 women in the world. So this is something very common. So I'm very sorry if there are people who are colorblind who are looking at this example, but these are some examples of data visualization which are rendered with different palettes. So for example, on the left, you have something rendered with the default MATLAB jet color palette. And on the right, you have the very same data visualization rendered with a palette called Viridis. Basically, even without talking about color blindness, if you compare these two data visualization, you can see that the one on the right is more readable. So it's easier to access to this data visualization because the choice of color is better. So this is like two standard palettes, but this is what happens if you simulate color blindness. So there's a good package called Dchromat, which simulates color blindness. So you can take your color palette and apply a function, and it renders your palettes, but it simulates the color blindness. For example, there are several kinds of color blindness. So there is one which is called deuteranopia. Sorry, I don't know how to say it in English, but this condition is simulated. So the jet color on the left and Viridis on the right. So if you don't have color blindness, you can easily compare these two graphs, and you can see that the one on the left is less readable than the one on the right. So basically, this is something you can think about when you are building your data visualization. So the most important thing is not finding something that looks beautiful, but something that that is readable, that as many people as possible. So this is something that the Viridis palette does. So there is a package called Viridis, and this Viridis package offers a series of palettes that are robust to color blindness. So basically, it works. You can still see the differences between the elements, even if you are colorblind, and of course, it's prettier than other palettes, and it works also on grayscale printing. So if you want to print the content, but you can only print in the gray, then it's also readable on these formats. So something very simple, thinking about color blindness, is my data visualization robust to color blindness? Can colorblind people still see, still understand, and can they still read my data visualization? So you can, sorry, you can simulate that with this package. And there's also another tool which is built in Google Chrome, so which is something interesting that you can also use, and it's not that very known, but if you go on Google Chrome and you go in your developer console, for example, if you have an R Markdown presentation, you render it and you want to see what it looks like for people with vision deficiencies, you can open it in your Google Chrome browser. You go to developer console, more tool, rendering, and there is a section called emulate vision deficiencies. So you can emulate some types of color blindness, but you can also emulate vision deficiency, so blurred vision, etc. So how to do it? You right click, you go on inspect, you go to more tools, you go to rendering, so it's really in your browser, and then you can emulate vision deficiencies. You've got blurred vision. For example, you can see all your slides are rendering if for someone who has a blurred vision, or you can also simulate with different types of color blindness. So this is for color choices. Another thing which is important to think about is people who are using screen readers. So there is, if you're interested in accessibility, there is this good Twitter account that you can follow. And this is a recent tweet about the cheat sheets from our studio are just empty documents because they are not readable by screen readers. So what is a screen reader? A screen reader is software that people who are blind use to read a web page. So they install it in their browser or on their computer, and they use it to navigate to a web page, and the screen reader reads what's in the screen. So some tips about making your graphs and your content more readable. Render stuff in HTML whenever it's possible, because HTML is easier to read than PDF. Something also important is thinking about how your, for example, your markdown document is structured, because you have different levels of headers, and they are used by screen readers to navigate in the page. There is also something called semantic HTML. So, for example, nav, menu, footer. So basically, the screen readers use these tags. So they go to the footer, they go to the menu, they go to stuff like that. They are using semantic HTML. So this is not something you can view on the rendered document, but it's used by screen readers. Something also is what is called alt text. So it's alternative text. So whenever you have an image, you can use something in HTML called alt text. So it's a description of what the image is and what it contains. Sorry, if you want to do it with Shiny, so in older version of Shiny, there is a function called tag happen attributes. It adds alternative text on an element. Yeah, so the feature about alt text in ggplot is a recent one, so it's in the most recent versions of ggplot. And there is, in the newer version of Shiny, you can use in render plots something called alt that can help you describe your plot. So basically, you can dynamically change the alternative text of your plot. So if you're building, I don't know, a dashboard for COVID or stuff like that, you can add alternative text to your plot, and screen readers are going to be able to read this plot. Something also about movement. So if you think about people who have trouble moving their hands, for example, they can have trouble moving a mouse. They can only navigate using a keyboard. Something very simple for Shiny, which is just allowing people to input a text and press enter and simulate something. So there is a cool package called Enter by John, who simulate this. So you can add an action on the enter key of your keyboard. Some tools. So where do you go from there? A lot of things to think about. Where to go next? So there is no tool that can ever replace real audits by a human. So it's great to start with something, but if you really want to make your tool accessible, please have an audit by a real human. To get started, there are a series of tools. So IBM Equal Access Toolkit that you can install on your Google Chrome and Firefox. I think there is also something you can put in your CI. So if you're using a GitHub Action or stuff like that, you can audit your application inside Google CI. Some tools on the W3 website, so webaccessibility.com. It has an online checker for web page. So you enter the link to your web page and you can test up to 5 pages. So I have a longer version of this on the inside the Engineering Shiny book. So it's chapter 6, the last section about web accessibility if you want to know more. And of course, I'm always happy to answer questions either by mail or with Twitter. So thank you. This is it, and I'm 16 minutes.
Colin, thank you so much for your talk. Inspiring. The comments that we're seeing are absolutely amazing, and thank you so much for giving us time. I can already tell you that there's been lots of chat on our Slack channel, and we want to have more of you in the future. So if you hear from us,
sure,
that would be the reason. Thank you very much,
Thank you for having me.
It's been an absolute pleasure, Colin. We really appreciate it. I am going to call a break now, and we're going to be starting back again at 12:24, please. If you can just try and come a minute earlier, so just so we can tee up, and then we can start our session at 12:25. So break now till 12:24, please. Thank you very much. Bye-bye, everyone.
Bye. Thanks.
Welcome back, everybody, from your break. I'd like to tee up our next presenter, who's Jessica Pang from Wales. Jessica, I'll just hand over to you in a moment. I just wanted people to know as well that on our Slack channel, we now have a stream dedicated to the conference, so feel free to join the Slack, us on Slack, and have a great discussion on Slack about the conference. Jessica, I'll start you at 12:25, please. I just want to make sure that you're good to go. So we can see your slides, so thank you very much. And perhaps if you could take the mic and introduce yourself, please.
Hi, can you hear me? Check it.
Yes, we can hear you loud and clear, and it is 12:25. Thank you.
Okay, hi everyone. I'm Jessica Pang. I'm an improvement analyst in Improvement Cymru in Wales. We sit within Public Health Wales. I'm also the AFA champion for the branch in Wales. So this is a Welsh presentation. I hope everyone's prepared. So anyway, I'm going to look at our journey to RShiny applications for COVID-19 sampling and testing. This work was supporting the management of testing in Wales, looking at the collection and testing times and testing turnaround times for samples for kind of Welsh residents and tests, analysing what PHW, Public Health Wales labs, and not really epidemiological work, which wasn't in our remit, just to make that really clear, because I know that Public Health Wales have done a lot of epidemiological work as well. I'm not sure I'm going to have time for questions at the end, but feel free to put anything in the Q&A, to tag me on the NHS-R Slack with any questions, and to email with the address that's on the screen there. So I am going to jump back a bit, because our journey to these dashboards didn't start with the COVID ones. So in 2019, 3 years ago, I'd done some R training before, but I never really used it on a real project. And then as these things happen, my team took on a program of work, complete new program of work, looking at the findings of the Emergency Laparotomy Collaborative in England and implementing those in Wales. Because it was something lifted from a different country, most of the overarching measures were already decided, with some differences in different interventions within Wales. And we originally used the ELC in England's kind of Excel workbooks to track these. They had things where you used national audit data, you plug that into some Excel workbooks, and these produce charts. But the problem with these is that they broke when new measures were added to the audit each year, and that created different cell locations. So we wanted something that was a bit more sustainable, that the teams we were working with could access anywhere. It took a while, but what we eventually produced in kind of the year that we were doing this work was what you can see on the screen now. And the libraries that were used in it, there aren't a huge number, but they're on the left. And some may have seen me present on how we got to this place with the EL Cymru dashboard in the Welsh Modelling Collaborative, something that's accessible to AFA analysts, but most recently in the peer support session in August. I did have help with the layout at the start of this, with something dashboard and screening in PHW had done, and that I'd learned about from a different kind of analytical forum within Public Health Wales. But other than that, search engines were my best friend, and I was going through trying to learn R, Plotly, Shiny, the Plotly and inbuilt functions, super powerful. And it was all about kind of discovering the art of the possible. And this dashboard had functions like, you can see there's a run chart on at the moment, that's a line graph with the median through it. It had the ability to create SPC charts as well, using kind of this tick function. And that was using QI charts to take the data out of the QI charts object and put these into a different graph. We also had the ability to create posters, and this was done using our Markdown and the download handler in Shiny to produce a Word document of a poster summarising the measures for teams to stick up in their departments. So it had a lot of different features to make it user-friendly. And that was kind of our first foray. And I do use that. All of the functions that I made were very inefficient and for very specific graphs when they could have been a lot better. But this is our first kind of move into RShiny. So in doing that, I'd learned quite a lot of the possibilities of using RShiny and combining it with Plotly. As said, it's super powerful. And I found that I gradually became more competent at using functions, and I could have and did rewrite some of my code to be a bit more efficient and a bit more elegant. It was easier to learn with the real project rather than after my initial kind of training. And that's because things go wrong and you have to fix them. You have to work out what's happening, and you're doing that using real data, which causes different problems to those pre-made exercises. And this put us all in a great position to implement what we'd learned about RShiny and do this at pace. So 2020 rolled around. I was still working on tidying up the ELC dashboard, fixing some of my code. And then I think we all know what happened. It's in every presentation I've seen for the last year, 2 years. And my colleague Adam and I were mobilised into working on the pandemic in PHW. So I was mobilised in a couple of different places, but for this, we were mobilised to support the COVID-19 sampling and testing work, which, as I said, was kind of an operational work stream looking at the testing labs in Public Health Wales and the turnaround times with that. So the start of my COVID-19 dashboard journey was to kind of create something to duplicate calculations of testing turnaround times that went off to Welsh Government, as well as trying to add some graphs to make these a bit more useful to the people who were running these centres. So this is the layout. You'll recognise it from the dashboard I showed you before of the EL Cymru dashboard. It was very much the same. And all that's changed really is those logos, colours and the content. I duplicated the tables that had been manually created, but made it a bit more sustainable because it was automated rather than trying to group pivot tables within Excel in the same way each week, and putting it in RShiny for easy access. It required a data pipeline with some manipulations for the drop downs that were in the left-hand side. You can't see them in this, but you'll see them in future ones. And my colleague Adam handled a lot of that side of this work. So we split kind of into data engineer, analyst roles in this piece of work, which we hadn't really done before. In addition to those tables, we added some simple graphs of turnaround times, some of the turnaround times and their distributions over time, and some improvement methodology graphs. And this was kind of getting us started on the road to improvements within turnaround times and looking at that from the different labs. What followed in the next few months was kind of a flurry of activity in which we adapted the dashboards I created to be more fit for purpose for operational use rather than the summary figures. We put in sections we wanted to complete in future to get comments from users about what they would want to see there. And there's a lot more work done by Adam behind the scenes, manipulating the data sets and really understanding the reality of what the process was, working really closely with the lab staff and managers on that. Most importantly, we added in operational definitions. So this was embedded in like tags, iframe, one of the kind of things you can put directly into Shiny. And this was, again, so we allowed comments on the calculations from those who would know the processes and data sets better than us. And we continued kind of on this vein. We added this sample received to authorize to look at lab performance rather than including transport times. This was something that the sample collected to authorize looked at when someone was swabbed up until when their test results were authorised to be given back to them. But that didn't accurately reflect the operational side of the work. And so we added that in. And we added buttons for operational definitions on the same page as those tables to make them really clear and easy to access. If I play this. We started to combine the graphs into the different timeframes rather than each measure. We added in more improvement graphs down at the bottom here. And we also added in some tables underneath some of the graphs. And that was for easy export for people who really wanted to know the numbers or had been asked a question about the numbers. And these were either user-friendly features, the combination into one measure type and the table information, or features to increase the usability and understanding for improvement. Oops, sorry. And we carried on by improving the understanding by changing the available filters to match lab understanding and terminology, and including some information about the number of people in different filter groups, and the extract update date. We also then added in one of the most valuable graphs in the end, which was looking at the percentage within certain timeframes over time. And this became one of the biggest things that we used. And we also took away some of the whiskers from box plots that we've done to make that more understandable for the people looking at them. After this kind of flurry of activity, we set to work rejigging the dashboard behind the scenes more to work in an efficient way rather than changing the way it worked and on a user perspective. And this was kind of using UI server files rather than app files, and providing better separation between the data pipeline and the dashboard, so it could all be used and extracted more easily and separately from each other. And that led to the creation by mostly Adam of different dashboards that were mapping tools more than dashboards, which allowed us to map using Leaflet and Shiny dashboard to look at testing rates. So this one is looking at where people tested at specific testing centre usually lived. And we had the flip of that. So if you're going to if you're living in a certain area, where are you going for a test? And that was to look at the accessibility of those services. And we also use this to look at data quality. So we had a couple of different channels of input to us. We were looking at a view on data in what was NWIS, now DHCW, which is our informatics service in Wales. And sometimes those links fell over a little bit, and we needed a way of looking at that. And there were also links further down the road in terms of to the non-NHS Wales labs who were still testing Welsh residents. So we needed to look at the turnaround times to see if we can influence those. And so all of this came together in this dashboard that we would look at before we were doing reports, so that we could give any information on why things weren't looking the same as usual in terms of numbers. 2021 rolled in. We carried on editing the dashboard and the data to make them as useful as possible. And we found a lot in the data sets and working with the labs again. So one of the huge things that we ended up doing was, sorry, that's not the right thing, is creating different, again, filters that were about the pathways. And this was linked to the different prioritization of tests within labs. We also included an improvement tab for the labs to start working on how the labs were performing. So this was looking at specific labs, so you could choose a testing lab and looking at how they were doing. And this could give a bit more information on why things were going wrong on certain days and that kind of thing. Eventually, the improvement tab was moved out of the main dashboard because it was really aimed at a different audience. And this meant that we started to create different tools for the different perspectives after this point. So this was the improvement dashboard, which was looking at where we could improve. And there was also one that was a laboratory dashboard, which was looking more at performance and looking at specific lab or lab type performance, and that was more of an overarching view. And this was looking at what's going wrong on this day or what, and how can we improve that. And we also looked at including a data usability tab for where we had a lot of missing time fields and things like that. And this was to pick that up and feed that back to lab staff so that they could improve that. Then we started July this year, really, preparing to hand this over for the long term. We removed a lot of the filters and data items that we weren't sure of or weren't really being used for the handover. And we were kind of constantly feeding back on that to see how people were feeling about it. And more recently, we did something similar to what I'd done in the EL Cymru work, which was make a button that downloaded the SITREP, which was a document that we were doing at first daily and then weekly for the teams within Public Health Wales. And we now produce a PowerPoint file and use kind of tags A again to directly embed, well, allow you to download that from the dashboard so that it's cutting out the work that we were doing before writing that report, which was necessary early on so that we could give a bit more feedback. But towards the end and going forward, it's going to be something that they can look at, knowing what we've said before and move forward with it. So in terms of the future, I've heard a lot more about different things that we didn't use and I feel like we could use. I mean, even today I've learned some things, but I've heard a lot more about Colin, and I had heard about modularizing RShiny apps in the NHS-R conference in 2019, I think, and I still haven't utilized this. But what I do know for sure is that these are the things that we've kind of learned. Save old code to use in future. There's no way the speed would have been as swift without the code that we had in previous projects and from other people. That feedback loops and iterative processes are so important. We need to know whether the product that you're putting out gives the information that's needed, whether you keep creating things that are useful rather than what you think is useful but maybe isn't to the people that are looking at it. Looking at those issues of the data set, the groupings of patients that aren't found in the data, but it's such as for us, how tests were prioritized, but are so useful in really understanding the process for people working in it. Using different views for different users, I think that is a generally good idea in dashboarding work. But again, to ensure that things are useful. Functions make everything easier in the long run. So it's really taking the time to master them is really important and can make things a lot more efficient and run more smoothly in the future. Networking and linking to groups and communities like this one. Everybody's doing a great job here. And this gives you the opportunity to learn new skills, things to implement, the art of the possible, and to get some help with code if you need that. We also want to talk about kind of documentation a lot more. We need to get a lot better at this, and it's vital for handovers and looking back on pieces of work for future work, and also SOPs where that's something that needs to be in use. Analytical pipelines in everyday situations. So this was our first kind of foray into really splitting into data engineering, data analyst kind of roles. But we want to start using the analytical pipeline side of what we've done to create regular data extracts that are clean, ready for our team and our wider improvement team to use in the future. And also that splitting of the data processing and analytical processes. And again, documentation will be key in doing this. Division of tasks that don't overlap when working in a group. So Adam and I divided our tasks so that they didn't really overlap too much and that they could be worked on really individually to increase that pace. We'd love to do more on version control. It's something that's been in our minds for years. I got most of the images for this talk from full saved apps that I created whilst I was building, but that's definitely not the right way to do this. And we'd love to get into doing branches. So in the last NHS-R conference, I saw some dashboards that were ultra transparent, open to editing, and that you could allow for quicker fixes and reliability in future. I think it's been mentioned that sometimes Shiny apps have, or are in general, is a little bit mistrusted in the NHS. And it's just about like that visibility of what we're doing, the understanding of how it works, and any tips on any of these things would be greatly appreciated. And that's it for me. As I said, in the Q&A, if you have any questions, or on Slack, or at this email address, would be great.
Jessica, thank you so much for your talk and sharing your experience with us, and also thank you for keeping to time. We do have a minute in case colleagues want to post a question. Some people have asked about whether not your data, but your code itself might be something that you're able to share in some way.
I think so. I certainly would share it to anyone who asks for like specific information, and I'll check. I think that the Shiny code in particular should be something we'll be able to share. If not, like maybe not quite the data manipulation, because sometimes the data teams.
Yes, I appreciate there's all sorts of, but that's great. Thank you so much.
Yeah.
Jessica's left her email address, so do feel free to follow up with Jessica, but that's lovely. Thank you very much. I'm going to move on to Ben, please, Ben and Emma. So if I could ask either of you to unmute and introduce yourselves and take the floor, please. Thank you very much.
Hello.
Hello, Ben.
Do you want to put your video on too, Emma?
So we can see your slides, Ben, and we can hear both you and Emma. Thank you very much.
Okay, well, we better get going in the interest of time then. So today we're going to tell you a piece of simulation modelling work which we did at PACE last year to inform some substantial changes to a local mental health system, which was made up of multiple interacting services rather than individual services in isolation. But in terms of the introductions, I'm Ben Murch. I'm now at NHS England Improvement, but at the time that I did the modelling part of this work, I was at BNSSG, CCG and Healthier Together STP. And Emma?
Yeah, I'm Emma Gara. I am Head of Business Intelligence for Contracting and Commissioning at Bristol, Somerset and South Gloucestershire, CCG and the Healthier Together system. I provided the BI leadership into the systems response from a mental health perspective when the COVID pandemic hit, and I was the customer for this piece of work.
Okay, so I should be trying to change my slide now. And we just wanted to point out that this was it was a relatively large project. So there are a lot of other people who made substantive contributions to this work who aren't today. So we had colleague Tom Hodger, who did a lot of data sourcing and intelligence, Richard Wood, who did a lot of validation of the modelling approaches, Julian Walker from one of our mental health providers who provided a lot of subject matter expertise, and Jenny Cooper, who was an academic from the university who gave some oversight and also carried on some next steps in this work. So in terms of a bit of background and motivation, in late spring 2020, there were increasing concerns nationally and locally that about the effect of services being suspended during the first COVID-19 lockdown. And that was combined with widespread experiences of isolation and trauma caused directly by the pandemic and associated lockdown measures. And we thought they were going to cause a surge in demand for mental health services in a system which was already seeing increasing demand under a lot of pressure. Did you want to come in, Emma?
Yeah, so our mental health services have got limited capacity and we're already struggling with high demand. And so we foresaw that after the first lockdown, there was likely to be a wave of suppressed demand returning back into the system. And we needed to understand how that new demand with the existing demand would impact on those services and understand the potential for those services to become overwhelmed. Stakeholders had lots of ideas around how that demand could be mitigated, but we didn't have any objective evidence or data that would substantiate the decisions that they were looking to make. So we needed to make more of a case to substantiate the reason to invest in more services.
Okay, and we needed to do this fairly quickly as well. So we did an initial literature search and it showed little in the way of existing intelligence or pre-packed modeling approaches, which we could use to do this. We know that at the same time as we did this, some other people were working on it as well, but at the time we had nothing. Data was patchy. There was limited understanding of how services interacted with each other, sort of where their boundaries were, how patients interacted with them, flowed through them, and in some cases even what constituted a mental health service, because there was some discussion about that beyond the specialist providers. So Emma spun up quite quickly a multi-pronged, multidisciplinary project involving stakeholders from across the system to look at sources of data, possible policy interventions, existing knowledge, and how to quantify some of the consequences of competing demand and capacity scenarios, which is where the modelling stream of the project, which I led on, came in. So in terms of that, we settled on this approach. We had a couple of main objectives. We wanted to take an existing service configuration, sort of the way a do nothing, the way things are in terms of waiting times, waiting lists, flows through the system, and what the services were. We then wanted to look at what would happen if we made some hypothetical changes to services in terms of arrival rates, flows between services, service times, and capacity at specific services, so that we could model interventions in that way. And we wanted to look at projected waiting times, waiting lists, and flows through the system under those. And we wanted to compare the the hypothetical interventions with each other and with the do nothing case. And there were some key things we wanted to take account of in doing this. So we're interested in variability in the arrival rates and service times. So we wanted to appreciate the stochastic nature of how the patients interacted with the system, because averages don't work very well in this case. And we wanted to look at the effect of waiting times on what happened to people. So the first point is common to all of these types of simulation modeling approaches. And I won't go into the details of it here, but in principle, if we remember that if we've got an average of 10 patients per day arriving at some service and they stay for an average of say 5 days, and you base everything on those averages, you might be unhappily surprised when you realize that some days 2 patients turn up and other days 15, and some are gone in a day, but others stay for a couple of weeks. I'll refer you to the literature and to other sessions at this conference if you want more detail on that. The second point might need a bit more clarification. So we wanted to assume that there was a natural preference for where patients would access services and where they would go next when they completed a particular service. But that if they were to wait for too long, then their condition would deteriorate and their choices might change. So they might need to escalate to a more expensive and higher intensity and less well-resourced service, or they might spontaneously get better. But they would leave the queue they were in and go somewhere else. So in the jargon of simulation and queuing, that we would say they would renege from their intended queue. It'd be easy to understand if we try and visualize what we mean by local health service here. So this is a high-level schematic diagram of the system we're looking at, and it's a simplified model of our mental health service. There's a lot of more moving parts that we chopped out. Each rectangle here, each of the white rectangles, is a service. Each of the circles with a letter Q in is a queue for that service. Each of the hexagons on the right of the screen is a way out of the system. And then each line, we've got dotted lines and solid lines, but each of these lines is a flow into or between services and exits from the system. The solid ones are the natural behavior I just talked about, and the dotted ones are when you've been waiting too long, you've got a chance of disappearing off on one of those dotted ones. And the grey rectangles that you see, which have these labels L2, L3, and so on in the background, are a high-level conceptualization of the sort of severity or of the intensity of that type of service. So these were used in some of the high-level negotiations, but and we originally were going to model at that level, but we realized that we had to have those individual moving parts of services in there to make it work. So on this, a patient will arrive on the left of the diagram, they'll flow down some arrows, and they will eventually come out on the right-hand side, maybe after cycling around a bit. And what we wanted to know was that for a given set of assumptions about arrival rates, service times, and capacity at each of these service points, what would the queue sizes be? What would the waiting times be, and what proportion of patients would go to different exit locations? And at the end, we've got a planned end, which is good, and the other ones are probably not so good, and might be consequences of waiting too long. And we made some simplifying assumptions. So we didn't cover all services. And in particular, we excluded some very specialist intensive services with small numbers of patients, like eating disorders, perinatal, mental health, secure psychiatric services. So we deemed them out of scope, but there was some follow-up work that looked at some of them. And then the second key assumption here is that many patients in reality never leave the system once they're in it. So a lot of mental health diagnoses are forever. But we didn't want to simulate everybody in our entire population flowing through the system. So what we did is we looked at defining a period of escalation. So if somebody had not had any contact for a long time, if they were deemed to have gone into a sort of period of low level maintenance, then we modeled them as leaving the system for that amount of time. So that's the high level conceptualization of the system. And then this is our sort of a computer or mathematical model of that system. So this is a very simplified version of the algorithm we used to implement this. And the approach we did choose was a method called discrete time simulation, or DTS. It's conceptually similar to discrete event simulation, or DES, which some of you might be familiar with. And the way they work is both of them effectively set a clock running, and then they tick through a simulated time period. I think in our case, we looked at 2 years. And it moves by, the clock moves on. And as the clock moves on, we move patients around the system. And we do it by sampling arrival rates and service times at the different service points from given probability distributions. So we're doing some Monte Carlo sampling there. And we sample the onward direct destinations from those once they've completed service at them using given transition probabilities, which are associated with the flow lines on the diagram on the previous page. And the main difference between a DES and a DTS is that in DES, each patient event is dealt with separately, whereas in DTS, we're looking at a slice of time, and we have multiple things that happen at once. So in DTS, the clock ticks on, and then you deal with everything that happened in that time interval in batch at the end of it. It's an approximation to DES, which would become exact if your time interval became sufficiently small. It has the advantage of not requiring quite as much computation. We had a lot of events to deal with. And also our clock interval was 1 day that we used in this. And that was, as we thought, a sufficient degree of approximation for the purposes at hand. The diagram on this is a simplification of how that works. So you start with some user inputs at this box on the top left. And our user inputs were a pair of CSV templates, which would set up your system. So you give names to each of your service points and exits, put the transition rates between them and how long people stayed at them and so forth. And there was also an R wrapper script, and this would be the one where you clicked to set everything going eventually. And it had a few sort of meta parameters about the simulation. So how many computer cores and how many CPUs in your computer you wanted to use, how long to run the simulation for, what length of warm-up period you would need to be to make sure it was running properly, and so on. That was all in an R script. So when you'd done that, when you'd entered those templates, you'd click the button on this wrapper script and it would set up in the computer the representation of your system, and then set a bunch of simulation loops going for that period. And it would do this multiple times simultaneously, which is these different gray boxes here are. So each of the loops would be a possible world given the parameters. And we create multiple possible worlds, different replications using the same parameters, but different random draws from the probability distributions, then average over all of those to get our estimates of the output measures and the indication of the range of their variability. And we chose DTS in particular because it appreciates variability. It's got that stochastic element, lets you produce service level output metrics, and gives relatively intuitive conceptualization of how patients are moving through the system. And in terms of actual code, this is some of it. So on the left, we've got our inputs, 3 CSV templates, a bit of this wrapper script, and then it has a bunch of other setup scripts, but this is a bit of the main guts of the simulation. I point out, actually, we wrote this all in base R mainly. We did use the data table package to deal with some of the outputs, but it was mainly in base R, and we did that because we wanted it to be replicable and maintainable and to understand exactly what it was doing. So we ran this model, and we used it to model 2 hypothetical interventions against our baseline. Each of these to hypothetical interventions was actually an amalgamation of multiple different interventions which are on the negotiating table. So we sort of amalgamated into a bunch of arrival, transition rates, capacities and service times at one or more of our service points, and looked at what the consequences of those would be. Under all cases, we expected an increased influx of patients into GP and specialist mental health provider triage services. We thought that lower intensity patients would in most cases be routed to an earlier intervention or to a social prescribing or a talking therapist type assessment. Under the first intervention, we assumed deliberate rerouting of patients into the psychological therapies, but without a big capacity increase. And in the second intervention, we looked at more early intervention strategies that would reduce demands on those therapies. We also looked at changes to some of the service types and capacities in areas. And what you see on the slide here are some outputs. These are plots over time of the queue sizes, and we also produced metrics on the waiting times and where people went as well. And this is looking over a period of 2 years, so it's a pre-lockdown period. Then you've got these vertical grey dotted lines, which is our lockdown period, where a lot of services shut down, and then you've got demand being flooded back into the system afterwards, and also if we had our interventions taking place after that, and we simulated it what was a year into the future at the time. The solid line here is do nothing. The dotted and dashed lines are our hypotheticals, and the grey bands are uncertainties over those estimates from the simulations. And without getting too much into the details of what these results tell you about that system, you can see different trade-offs in decisions about where to route patients and how they propagate through the system. For example, in both hypotheticals, you see pressure on the long-term intensity services at GPs. So this is patients who in theory need more specialist management, but there isn't any for them, so they end up being managed by their GPs, which is not ideal. And when they've been bounced back from elsewhere. And we also see a trade-off between that and the queue sizes in other parts of the system. But the key point was that this allowed some comparison between what was already happening, what our hypothetical changes were, where bottlenecks and pressure points were in the system, when looking at the system as a whole, rather than just looking at some individual services. And this was then used alongside some other approaches to inform high-level decisions about what to fund. And Emma's going to talk a little about that now.
Yeah, so this is sort of a recap of the whole process and what happened. So we recognised early on that the pandemic was going to have a significant impact on people's mental health, that we needed to understand the impact of that demand on the whole complex system of mental health services. We researched whether there were any other models available, and there weren't, so we commissioned this piece of work. We knew we needed to act fast to inform timely decisions, so yeah, we commissioned this project. As work went underway to construct the model, we produced other service and population-specific demand estimates, and they were used to inform cross-system stakeholders, generating a large number of potential mitigating projects. But on their own, those summary statistics did not show the overall system impact. With the model, we were able to group the planned interventions and test the alternative aggregations against the do-nothing scenario, as Ben has explained. The results provided a much deeper window into the potential consequences of different choices. The practical outcome was to strengthen our case to invest in preventative interventions. The model outputs and other analysis contributed to a business case, which led to our System Mental Health Board reprioritising £3 million of funding to over 25 mental health projects. The project generated a lot more interest among the stakeholders to use quantitative and analytical approaches to inform decision-making on an ongoing basis. Examples have included modelling psychiatric intensive care services and a data-driven population health management approach to redesigning our community mental health services.
Okay, and that sort of brings us to the end. So that was progress to date. We wrote up this work and published it in a peer-reviewed scientific journal, Operations Research for Healthcare. So if you want to know more details, I would direct you to that link on the right. And we've also shared the code and some dummy templates, and some example, some dummy data, as well as the format of the templates on GitHub. So if anybody wants to use it themselves, they can do, caveat emptor. At the start of the project, we couldn't find any approaches, so we think that we've made a certain progress, even if this wasn't the code you wanted to use yourself in the end. It gives you a lot of detail about how we went about our approach and what you could do yourself to solve your own problem. So that pretty much brings us to where we are. It's been a bit of a whistle-stop tour, I know, but if you've got any questions, then please do get in touch with us.
Ben and Emma, thank you so much, by the way, for I've just put in the chat how these tools, this work of bringing together informatics in a way that can support decision makers, and then the investment changes that happen as a result of it is absolutely astonishing, especially for mental health. So if there was a way to give a round of applause to all our speakers, in reality, of course we would, but really just a big thank you to you and Emma for sharing your work with us. And I'll just highlight again, one of the points that Peter made really was things that are a black box often from the private sector. And here we're seeing work which is not only transparent, but is of publication standard. And that is one of our measures of high quality work. So it is absolutely amazing and a privilege to be part of the community and see this kind of work happen. We're due for a break now, and we're due to come back at 1400. So I will wish you all a well-earned break, and we will see you at 1400 for our lightning talks, please. And just very quickly before I do that, there is just a quick message about a lunchtime social get together. So if I can just find that message, I'll just put it up. But Zoe and Tom have kindly agreed to a quick social at 13:30 till 1400. And everybody's welcome to come there just to have a quick chat, and please feel free to bring your lunch as well. And thank you to Tom and Zoe for agreeing to host that for us. So have a lovely break to join the social, and we'll see you at 1400 hours. Thank you, everybody. Good afternoon, everybody. Welcome back to this afternoon session. We're due to kick off in 5 minutes' time, but I just wanted to welcome our delegates and also our speakers. Can I just check if somebody could just give me something in the message to say that they can hear me, please? Thank you, Annie. And Annie will be our host, our chair for the lightning talks. Can I just give a big thank you to everybody who's volunteered to support our conference, and in Annie's case specifically, Annie's really active on our Slack channel, gives real-time help to our questions, and also for the first time offered a workshop on interactive plotting, which went down really well. And Annie's also kindly agreed to be chair for this afternoon session. Just a quick kind of heads up to the speakers, please do keep to time, and if Annie or I interrupt you, it's not, please don't be offended, just be gentle with us, and we are looking forward to the amazing talks that are lined up for this afternoon. So I will hand over to Annie, but we will start at 14:05. So maybe Lee might tee up Lee's slides at 1 minute before time. So I'll pass the mic to Annie. Thank you.
Thank you, Mohammed. Very happy to be chairing this conference today. Hi, Lee. I noticed that you started sharing your screen. Are you good to start early? We can still wait 3 minutes.
Yeah, I'm good to start early. That's no problem. Yeah, I can kick off now if you want.
Okay, that's brilliant. So hello, everyone. So the second half of this conference is going to compose of a series of lightning talks, 10 minutes each. To start off, we've got Lee Coulson, Senior Information Analyst from NHS Devon CCG. And I see that you've already got your material all set up and ready. So floor is yours.
Thank you. That's great. My name's Lee Coulson. I'm going to just take you through quickly how we can do animated choropleth maps, just using around 40 odd lines of code in R and a little bit of wrangling with an image manipulation program. So I'm going to step through some code. It's not going to be very much. And just to give you a quick feel of how easy it is to get this set up. So the original ask was our guys who work in the Devon Digital Accelerator program. They're responsible for getting practices up online with eConsult. So this started a couple of years ago, and obviously in a bid to reduce GP face-to-face appointments, probably a bit opposite of the situation we are in now. But either way, they approached us saying they wanted to be able to show a animated map of eConsult take-up over England, for them to be able to put into a paper for like an awards ceremony or something. So we started off, they gave us the data. So we have the data for each CCG in England. We've got, as you can see here, we've got the CCG code the ONS CCG code, what month it is, and the number of e-consults, okay, all NA for this particular CCG. We then merge that with the CCG boundary files, the geospatial files, so downloaded from ONS, and you can see here there's lots of attributes with it. The main one I'm really interested in is this polygon, so we can plot it, so the geometry, which is these polygons here. We then look at splitting our data set, so just pulling out the unique months. This is so I can just simply loop through them to create a heat map or choropleth map for each single month. I'm then splitting off my count of, or setting up rather some bins for my count of e-consultations. So we want to show like a sort of logarithmic.
Lee, can I just ask you to hold a moment, because apparently we're not seeing your slides. So or we are seeing your slides, but some other speak. I'll just wait just for our colleagues from WTV just to reassure me that I think everything's okay.
Yeah, it says here on screen sharing, okay.
Okay, Mike's okay. So maybe it was only one.
I'm Mohammed from WTV. Everything looks fine from our side as well. We can see slides, we can see the screen, so everything looks fine. Thank you.
Okay, yeah, thank you. Please carry on, Lee, carry on.
Okay, no problem. You can see all the stuff coming up in the console then as I flick through the code, okay, I'm assuming. Right,
yes.
Okay,
yes.
No problem. So I've set up my palette bins to basically group my data into each bin, dependent on the amount of e-consults they've had. And next is I set up my palette of colors, just taken from the blues color map. You can plug in lots of different color maps to Leaflet. And I'm then now going to set up a suffix so that I can label each of my maps, so 1, 02, 03, etc. And then what I do is for each month, I'm going to pull out all the e-consults per CCG and just simply join them to the CCG boundaries file. And what that does is I then can display that choropleth using Leaflet. I can color my CCG, or the amount of e-consults per CCG, if you like, by this sort of heat map we've got down here that you can see. And with a few simple lines of code, we can put into Leaflet my CCG boundaries data frame, which has the e-consults added to it for that particular month. We can select here the fill color. Here's where I'm giving it my color palette function that I set up here. And I can give it, I need to give it some other parameters such as a layer ID, and then how am I going to demarcate them with just a white line essentially, and making them slightly transparent to be able to see the place names underneath. So when I run that, I get this map that you see here. So this is just for one particular month, and that gives me this heat map that shows the e-consults around the different CCGs in England. There's then another command here, the map shot. This then saves the file onto disk. So I end up essentially with 35 or so map files here. So I could, when I looked at it before, I could then use R to create an animated GIF of all those files here, but they were going to be extremely large. So because basically each file is around a meg, and when I looked at it, the resultant GIF would be about 35 meg. So to keep it short, I used this program, this image manipulation program called GIMP. And what I can do is I can load all my files in as layers, and I've got all 35 of my different pictures here. And with a few clicks, I can create an animation for this. So if I select filter animation and optimize for GIF, what that does is it reduces the size of my images by, instead of creating it from 35 1 meg images, it only, each time it increments, it only uses the parts of the image that's different from the time before. So essentially I can do that. I can then export it as a GIF. I can, when I click export, it comes up with some options for me. So I can tell it to loop around forever. I can give it, the crucial one here is the delay between each picture. So I'm giving it ½ a second. And when I click export, it'll export that to disk for me and save it as a GIF. And then if I open that now, I can show you the end result, which is I have this GIF file, which then every ½ a second updates my eConsults or updates my picture. So it gives me that animated picture. As you can see, it sort of slowly started off. Uptake really ramps up once you get past sort of COVID. So what, February, March 2020. And this just loops forever, running this animated picture. The good part of it is because it's a simple file. So they wanted basically a file to be able to pop into their presentation. So they could simply copy and paste that GIF, that picture into their presentation and submit that with their report. Okay, that's probably it from me. Thank you.
Thanks so much. Leaflet is such a powerful package, and that was a great example of what you can do using it. So thank you for that, Lee.
Yeah, no problem. Thank you.
No worries. Okay.
It is very simple to use, Leaflet. I found there's a great tutorial online for it. Just to simply get a map up and display, add lots of layers to it is no problem at all.
Oh, that's brilliant. If you can link that tutorial in the chat, I'm sure that people will be very happy to see it. Yeah. Cool. Well, is Anne Amarilla online?
Yep.
Hi, Anne.
Hi.
So you're a senior data analyst for the Health Foundation. Welcome. Whenever you're ready, please feel free to start sharing your screen and go ahead.
Cool. Can I just check that that's sharing? Fine.
Yes, I can see that.
Perfect. So hi, everyone. Thank you for having me. I'm really here to share our experience of analyzing survey data using R, and really just to increase awareness on how useful it is to do so. Just to give a bit of context of how this work came about. Our previous work highlighted the impact of the pandemic on care workers and users of social care using patient and public level data, so like admin and primary care data. However, there were gaps in the available data, which meant we had an incomplete picture on the impact of the pandemic. For example, we couldn't assess the impact on unpaid carers, even though they played a significant role in the health and social care system. So we looked at other available data sources, such as survey data. We were interested in exploring who was providing care during the pandemic and the impact this has on their health and health-related outcomes. There are differences to using admin and survey data. Admin data is routinely collected. However, it relies on the population being in touch with the system, which is not always the case, particularly with unpaid carers. Also, the metrics you have are obviously useful, but may not provide a complete picture because it's not driven by research interests. Survey data, on the other hand, is collected for research and has the infrastructure to be a bit more reactive in their data collection process. And they're also able to sample underrepresented individuals, as well as provide information on intentions and behaviors of the population. Another upside of survey data is this generally open access and can be accessed through UK Data Service. For our analysis, we used the UK Household Longitudinal Survey. This is also known as Understanding Society. This is an established longitudinal survey looking at health, social, and economic changes in the UK population. Separate from their main survey, they have a COVID-19 survey that monitored the ongoing impact of the pandemic. Just to reiterate, we were interested in who was providing care during the second wave of the pandemic and the impact this has on their health and health-related outcomes. We made a distinction between those providing no care, those providing less than 20 hours of care per week, and those providing 20+ hours of care per week. And our analysis is mainly descriptive in nature. Analyzing survey data is not as straightforward as admin data because it uses complex sampling techniques, or the survey design, in order to gain a representative sample of the population. I'm going to talk about this in crude terms because I'm no means an expert and only in relation to understanding society. But I should note that there are many different types of complex sampling techniques, and it's important to know which one the survey has used, as you need to account for these in order to produce reliable estimates. You can usually find the information in the dataset manual, or if you ask the survey owners themselves. For understanding society, they use 3 types of complex sampling features. First, they stratified the population into regions like so. They then randomly selected clusters of addresses via postcodes. This is known as clustering, and it's done because clusters, addresses within the same cluster are more similar than addresses from different clusters. They then needed to adjust for the probability of an individual being sampled from a given population and the probability of an individual responding to the survey from a given population. These are known as weightings. This is because some groups are overrepresented in the sample by design, while some are more likely to respond than others, and we need to account for these so that their results doesn't skew the findings. Choosing the right weightings can get a bit complicated as there are various reasons or factors that you need to account for, such as the type of analysis you're doing, so if it's longitudinal or cross-sectional, the type of population you're after, are you just looking at the adult population, are you looking at children as well, and the time point that you're after too. So choosing the right one is important, but it can be tricky. Thankfully, there's plenty of support available. For example, for understanding society, they have tutorial videos on which weighting variables to choose. They also offer training days, and you can also get in contact with them for support, which I actually did for our analysis. So survey data is typically analyzed using SAS, SPSS, or Stata. And this is reflected by the available code out there and the format in which the dataset comes in. But R offers great equivalent packages for analyzing survey data, and I'm finding more and more tutorials on how to do so, which is really promising. So now I'm going to talk you through which packages we use in R in order to run our analysis. First, we loaded in the Stata file using the Haven package, specifically the read Stata function. I think using this package, you can also read in SAS and SPSS files and write onto them too. And I think this is also now part of the tidyverse package, so that's great to hear. The main package that we needed is called survey. Using this package, you're able to specify your survey design. Like so, using the survey design function, I was able to specify our clustering, our stratification, as well as our weightings. And then I'm able to use this survey design object onto my subsequent analysis. So for our analysis, because it's descriptive in nature, we very much just utilize the summary statistics available, like the survey table function, where we created frequency tables whilst accounting for the survey design. But to be honest, we were only scratching the surface when it came to analyzing survey data, as there are many other useful functions that this package has to offer, such as computing means, fitting generalized linear model, as well as survival model, and even creating your own plots using this package. But I think the great thing about this package is you're able to use it with established data manipulation techniques such as dplyr or tidyverse, as well as data visualization techniques such as ggplot to create your own bar plot like so, or even manipulate it to a way where you can create your own Sankey diagram using the D3 package, which I know does take quite a lot of data manipulation, as I learned it from a previous NHS-R tutorial. Like I said, our analysis is mainly descriptive, so our outputs are very much graphs and tables. And it's really great that we can use packages in R like GT Summary. GT Summary produces presentation-ready tables, and we were able to apply the survey design object onto this package to produce formatted summary statistics like so, which saved me quite a bit of time when I was delivering my outputs. So in terms of our findings, we found that many people started providing care during the pandemic. Around 2/3 of those providing care during the second wave were not doing so pre-pandemic. Secondly, we found inequalities on who was providing care and the type of care provided. So women, particularly those responsible for childcare, and those from some minoritized ethnic groups, are more likely to be providing longer hours of care per week. Finally, carers are at risk of poorer health outcomes, and the physical and mental well-being of those providing 20+ hours of care are worse than those providing no care or less than 20 hours of care. So those providing longer hours of care are more likely to have complex needs of their own. If you'd like to read more about our findings, as well as what we think this means in relation to support for unpaid carers, I've attached a link to our blog on the slide. As I said earlier, we were only scratching the surface when it came to using R to analyze survey data. But I think even so, we've demonstrated its flexibility as well as wide range of functionalities. And it would be good to get more people analyzing survey data using R. Our code is available on our GitHub page to build on, and you can usually find repositories from the survey that you're using. So for example, for Understanding Society, they have their own code repository, which I actually used to build on for our analysis. Thank you so much for listening, and I'd like to acknowledge those who made this work possible.
Thank you so much, Anne. That was very interesting. I had known that the survey package and the GT summary functions existed, that would have saved me a lot of time during my dissertation. So thank you so much for sharing those.
That's great.
Okay, next on the agenda, we've got Sebastien Peytrignet. They're a data analyst from the Health Foundation. Sebastien, are you online?
Yeah, can you hear me now?
Yes, I can hear you.
Brilliant. Let me just share my screen.
Oh, also, Anne, if you are still online, can you drop the GitHub page in the chat because someone has asked for it out of interest? Thank you.
Can I just check that the slides are visible?
Yes, I can see it.
Yeah, brilliant. So good afternoon, everyone. It's a pleasure to be back at NHS-R. Today, I'll be giving a short talk that draws on some of the work we did earlier this year with the Outpatient Transformation Board of UCLH. So you probably saw the title and you're wondering, what does online shopping have to do with algorithms or with outpatient care? So I promise it'll make sense by the end of the talk. But in a nutshell, hospitals want to understand how often patients are coming in. And for those with more complex needs, what combinations of specialties they're seeing. So whereas someone in marketing would like to know what's in people's shopping baskets, we would actually like to know what specialties people are seeing. And so that booking teams can help coordinate care better. So better coordination of outpatient care is a priority for a lot of trusts now. And as people have more and more comorbidities, this will become even more important. So a bit of background on how this work came about. So earlier this year, my colleague Fiona and I started a project with UCLH. So that's University College London Hospitals. This is a picture of the main site near Euston train station in London. And it's one of the biggest trusts in the UK with on average 400,000 outpatient appointments per year. We worked with two members of the Outpatient Transformation Board, and they had three main questions that they wanted us to look at. So number one, they wanted to have a better understanding of their so-called high-use patients. So this is pretty striking because about 3% of their patients are responsible for 1/3 of all outpatient attendances. Then they wanted to understand which services were seeing the same patients, either over the course of the year or during the same day. So why are they interested in this? Because if they know what specialties are seeing the same patients and at the same time, this is really useful to try and reduce the number of times patients need to come into the hospital. So it will help them move towards more of a one-stop shopping system where that's appropriate for patients. So before I get into the market basket analysis and the R code and all of that, let's just have a quick look at what the data looks like. So UCH switched on an electronic healthcare record system called EPIC in 2019. And for us to do this work, they gave us a 2-year extract. And so this table is more or less what's in there. So you have one row for each attendance. So it's a bit like HES data for those that are familiar with it. You have info on the patient, like their age, sex, deprivation, and you also have some information on the attendance, like the date and time, whether it was face-to-face, which specialty, the division, and whether it was a follow-up or not. So it doesn't have super detailed clinical information like what the attendance was for, but it's enough for us to get a sense of some of the patient trajectories. So this is just the timeline below here is a typical patient. So they had 3 attendances in the same week, trauma, orthopedics, and imaging. So we can guess that they probably had an accident or a fracture, that sort of thing. And then they kept coming back once a month for follow-up appointments. And during those follow-ups, they were either seeing a combination of ortho and imaging, and then later on, ortho and physio. So faced with this problem and with this data, we started looking for a data mining tool that would help us kind of find out which combinations of services people were seeing at the same time, so that we could understand where coordination was already taking place and summarize that back to our colleagues at UCH. Okay, so how did we do this? We used a method called the a priori algorithm, which is used a lot in marketing to find out what type of things people tend to buy at the same time. So, for example, people like to buy sandwiches, crisps, and soft drinks at the same time. And people use that data to come up with promotions like a lunchtime meal deal. But it's actually useful in a lot of different settings. So I'll show you how this worked for outpatient data. And luckily, actually, the method isn't that complicated because essentially you're not doing any complicated modeling, you're just counting things. So the way it works is that you provide the algorithm with a set of transactions, or in our case, care contacts, and those are labeled by specialty. So it looks a bit like the trolleys that I put on the right. And the algorithm starts counting each combination of specialties, so like neurology and dermatology and so on. And it starts with combinations of 2, and then it moves on to 3, 4, 5 specialties. So you do need to specify some tuning parameters so that it doesn't run forever, because you probably don't even need that much detail. Okay. How do we do this in practice in R? We used a really cool package called A-Rules, which stands for association rules. So first, you need to prepare the input data so that every row is a hospital visit and each of the specialties are separated by a comma. So it's like a string. And once you've been able to format the data in that way, you just feed it into the a priori function alongside the 2 tuning parameters that I just mentioned. So there's a bit more to it. Luckily, there's some really good guides online. I put a link here to guide. I'm happy to put it in the chat afterwards. So if you follow that, it'll give you some like dummy data that you can use and to practice and try and do this for yourself. Okay, so once the algorithm is done running, it returns the top combinations of specialties. So this is the kind of basic table that comes out of the method. So let's look at the first line. It's labeled radiotherapy, arrow, oncology, and it has a confidence of 86%. So what this means is that if you had a radiotherapy appointment, you're 86% likely to also have an oncology appointment on the same day. And one thing to be careful with is that the arrow doesn't mean that one appointment took place before the other. It refers to the subset. So, for example, the line just below is oncology, arrow, radiotherapy. And only 30% of people who saw oncology also saw radiotherapy. So just like to be a bit simplistic, that's because not everyone with cancer will receive radiotherapy. So how do I display all of this in a nice graph that I can show my colleagues at UCH or my clinical partners? Luckily, the A-Rules package makes it easy to plot all of this into networks. So I'm sorry, because the font's quite small, so you probably won't be able to see all of the labels without zooming in. But yeah, these kind of like neat networks come out of the package, which are really useful to summarize the results. So I can very quickly summarize what we found. So over the course of a year, obstetrics, maternity, and gynecology tended to see the same patients. And that's not really surprising because those are the kind of standard appointments that you have over the course of a pregnancy. Oncology and radiotherapy also saw the same patients, which makes a lot of sense. And so did orthopedics, physio, and hand therapy. And so did some of the kind of pre-op assessment type of appointments. So pre-op assessment, cardiology, and surgery. But in terms of same-day coordinations, so attendances that are happening on the same day, we found that the two places where this was very advanced and happening at a much higher rate were cancer and pre-op assessments. So those are the two areas at UCH, based on the work we did, that are already doing quite well in terms of appointment coordination. Okay, so I hope you learned something from this. There's a lot more that we could do with this data and with this method. And it's a pretty versatile approach. So I have colleagues that have used it to see which read codes tend to appear together in primary care, to assess comorbidities. It's also been used, for example, to identify side effects that tend to happen at the same time after taking certain drugs. So yeah, it's a lot you can do with it. And if you thought this was interesting, please get in touch with me or tweet about this. And that's it for me today. Thanks.
Thank you so much. Sounds like a very versatile algorithm. And thank you so much for showing the example of how you used it for patient care. Very interesting stuff. Thank you so much. All right. Now, next we have Tom Jemmett, Senior Healthcare Analyst from the Strategy Unit. If you're online, Tom, feel free to start sharing your screen and go ahead with your talk.
Yeah, just trying to share my screen now. So hopefully you can see my slides. So yeah, I've put a couple of links into the chat, so you should be able to follow along with these slides at your own pace if you want. We'll come back to them later. But I'm going to try and briefly introduce object-oriented programming in R using S3. I'm not really going to explain a lot of the details on object-oriented programming today. So if the concepts of OOP don't really make sense, I've put some links at the very end to read through in a bit more detail. But I just want to start explaining what is a pretty fundamental part of R to you all today. I'm going to really gloss over this largely because my director went through over the strategy unit earlier on in one of the first sessions. But just to kind of point out again that we're currently hiring. So if you have a look on our website under the careers section, it's a couple of interesting posts, and there's a bit of detail about me. But yes, what is OAP? And I'm going to try and explain this with the summary function in R. So it's probably something that we've all used once or twice, or maybe quite a lot. And this isn't the summarize function from Zplo, it's the base R function summary. But it's quite useful. I mean, we can throw in a set of numbers and say summary, and it gives us a nice little list of the range of values and the quartiles. And then if we pass in different types of data, it gives us different outputs. I mean, characters aren't that useful. It tells us how many things there are in it. But if we pass in a data frame, we get a nice set of statistics coming out for each of the different columns of data. So yeah, very similar looking kind of data from summarizing numeric values for the numeric columns. And these are factor columns, and it counts how many of each thing in that factor appears. And where we've probably seen it most is with things like linear models or other types of models, where you create a model first. So this is just a pretty dumb model using the Palmer penguins data set. Just trying to model how heavy a penguin is going to be based on their flipper length. And yeah, we can use the summary, and it tells us whether it's a good model or not. It tells us about the coefficients. So the question should be, how does this happen to, how does it know how to do different things for all of these different data types? And we could probably think of one way of trying to implement it. So here's some kind of pseudo code. It won't actually run this way, but yeah, could we build it with a big long list of if and else statements? And imagining that there are some kind of functions that actually deal with the underlying logic for summarizing a numeric value or a character value. But yeah, we can already sort of see what's going to keep happening here. And we're probably already starting to think that something's a bit amiss here. Though we're probably quite happy sitting there and just pretending everything's working fine. But yeah, the people that develop R and build summary function, they're going to have a bit of trouble maintaining this, because if they're building a big long list of if-else statements, they're going to have to handle every single case of each different type of data that ships with R. And then of course, we've got loads of packages on CRAN that create their own different types of data. So the base R developers would also need to support every single type of data that's on CRAN. And if you want this to be kind of useful in general, I mean, people will be submitting new packages to CRAN before a new R version is released. So they're going to have to support every single different type of data that could appear before the next R release. And yeah, I mean, that's not going to work, is it? So we could have a look at the actual function definition. So in this case, we're using the function get, which is just going to find the function for us. And it's literally 2 lines of code. You've got function that accepts object and any other argument that you pass to it. And then it calls this function use method. So yeah, what does use method do? And if we read the documentation, it's saying that it allows us to use some kind of object-oriented style of programming with method dispatch taking place based on the classes of the first argument. So I'll try and break that down a little bit for us now. But the kind of important thing that we're going to need to do is it's going to dispatch based on the class of the data. So if we went back to the earlier example, we could have a look at the class of the myNumbers argument, which was just a numeric vector that we created before. And the class function just returns whatever class that data type has. So in this case, it was numeric. And the characters, it returns character. I'll skip over data frame for a second. Yeah, linear model just returns LM. But in this particular case, using the penguins data, it returns 3 things. It's returning a Tibble DF, a Tibble, and data frame. So we can have one or more classes per data type in R, and every single type of data will have a class, at least one class. And you kind of read them left to right, left being the kind of more important one, shall we say, going down to the right one, which is the least important class. So the summary function is what we call a generic. And it's going to look at that object as we pass it to it, run the class function, say, what classes does this object support? And then it's going to try and find a function. And it's going to try and find a function that's named like this. So if we were dealing with the LM example, it's going to look for summary.lm. If it doesn't happen to find a function called summary.lm, but there's more than one class, it will try the next example. So with our data frame, it'll first try summary called df, before eventually falling back to summary.tl, and then finally doing summary.data.frame. Finally, what it'll do is try a summary.default, and if there isn't a summary.default function, it will throw an error. So that summary function is quite useful, but it turns out that these generic functions are absolutely everywhere in R. So the concatenate function is generic. The plot function is generic. So most people assume that plot is just for base R plots, but ggplot objects will work if you pass to the plot function. It will know how to draw that thing because there's a generic function for a ggplot type of data. If you pass in a numeric, then it's going to just do the base R plots. I think it's a bar chart, is it, for just a single set of numerics? The print function, whether you use it or not explicitly, anytime you write something into R in the console, it calls that print function, sort of. Some of the built-in data types like numeric and character don't call that print function, but most of the data types, like if you call ggplot and type it into the console, it'll call print, and then print will call plot. ggplot is itself generic, so you can pass in different types of data other than just the data frame. They usually do just pass the data frame to it. And most of the dplyr verbs like mutate and select are S3 generics. So we've got those functions, but it's really easy to create our own generic functions if we want to. So if we wanted to handle some new different type of thing, but it needs to put lots of different types of data, we can create a function that just looks like that summary function, just calling that use method, and then you give it a name. So usually you call it after the function that you've created. And then anytime that you call my generic with an object, it's going to try and find sorry, I've got a typo there, but it's going to try and find my generic with those arguments like this. And in this case, I'm saying that my generic supports data frame. It's going to call the function do stuff. For a linear model, it's going to do something slightly different. Obviously, for sake of brevity, I've not implemented what that function might be, but that could normally be all of the definition of the function, or you can call another function or if it whatever you want to do. So the last kind of point on this is, can you create your own classes of data? And it's really easy. So in this kind of toy example, I'm creating some data that just tells you a little bit about me. So say this is a list that contains an item called name, where I've put my name, I've put where I work, and I put my favorite type of food. And unfortunately, you'll see how this doesn't quite work in R Markdown, but it looks beautiful in RStudio. So for this class of data, I just implement a print function. And in this case, I'm just going to give a nice little output showing that data as a string. And that's how you implement your own class of data. You implement whatever kind of generic functions that you're interested in. Go with that. I've also given an example of using the data frame here, but I'm going to kind of skip over that for now. For the sake of time, you can kind of go through and read what is happening there. And that's pretty much it. S3 is ubiquitously used throughout R. Really important kind of to understand how it works if you want to develop your own packages. what next? Go read the Advanced R book. Great chapters on object-oriented programming. And that's about all I've got time to say. Thank you very much and enjoy the rest of the conference. And a big thanks to Sylvia for creating this beautiful NHS-R theme for sharing them. Yeah, thank you all.
Thank you, Tom. And do feel free to refer to Tom's slides that he shared in the chat if you want to look at the code in depth. Okay, next on the agenda, we've got Martine Wauben, who's the interim head of data science from DHSC. So welcome, Martine. And if you're ready, you can start sharing your screen.
Amazing. Let's just get on that. All right. So, hi everyone. I'm Martina. I'm in DHSC, and I'd like to talk to you about consultations, which are really just a kind of survey. So it was quite nice to see the service package earlier. If you've ever worked in a consultation before, a consultation is essentially a very big survey, which we run whenever there's a new policy idea or whenever we want to ask for evidence around the policy area that we're working on. And the general public gets to basically have their say, tell us their opinions about the policy we're proposing. They're very important, and they're a really important source for us as evidence. But they take a lot of work to do because we're tagging, verifying, tabulating all of the questions. And that goes for both quantitative questions, which are basically categorical ones where you can count how many people said a particular thing. But even more time intensive are free text questions where people type basically in a more nuanced way what they are thinking. And that traditionally has taken a lot of manual time to analyze. Automation can free up some of that social researcher time so that social researchers can spend a lot more time actually looking at what's been written to get that kind of nuance out. So I'm going to talk about a specific consultation that happened earlier this year about making vaccination a condition of deployment in older adult care homes. So it was something that's going to affect care home staff. And the very first thing we did was basically look at what the normal process is. So this is something that I imagine a lot of you will recognize. Traditionally, people would load data, then you've got loads of spreadsheets where people are cleaning that data, then you get even more spreadsheets where that data becomes charts, and then at the very end you have to quality assure all those spreadsheets because you can't quite work out what happened to what when. And here's how we thought about this particular problem. So here, I'm aware this is in colorblind friendly. The green tealy color are all the scripted steps. So we loaded the data, then we looked at categorical questions that had an other please specify section and coded that using regular expressions. And after we coded it, we could just create frequency tables as normal. And then for free text questions, we applied a topic modeling process, which was automatic itself. That outputs topics that then need to be manually labeled. And finally, we could turn those into frequency tables again. So let's talk a little bit more about what topic modeling is. Topic modeling is an approach where you take all of your responses, also known as documents, and you essentially try to find clusters of words that people tend to use together. So for example, in social care, you might talk about things like safeguarding, residents, safety, those kinds of words all come together. Whereas if you might oppose mandatory vaccine, you might talk about things like freedom of choice, coercion, or medical exemptions. And they might all occur in the same responses. Once you've found those clusters of words, you then look back at the documents and you find that each document is actually a mix of topics. So like in real life, people have multiple concerns, people have multiple things that they are telling you about. And so we allow that to happen. We allow each document to be a mix of topics of those clusters of words. So what does that look like in reality? It looks something like this. So on the left-hand side here, you can see a couple of these clusters of words that we found. So for example, topic number 22 is about informed consent, safety, mandatory coercion. These might be people who are concerned about making vaccines mandatory as a freedom of choice thing. Whereas topic 21, next to it, is protect, care, duty of care, vulnerable service users. These might be people who might be more pro a mandatory vaccine because of a duty of care to residents. And on the right-hand side, you can see that, as we'd expect and as we'd want to, most people have multiple concerns at once. So in each response, we'd see around 4, 5, 6 topics, because people often don't have just one reason. They disagree or they agree with something. They have lots of reasons at the same time. And we want that kind of nuance when we're looking at these results. So using this kind of method, what does that mean? Well, what it means is that, as you all well know, it means that everything is automated. You can prepare well before the consultation closes. As respondents are still completing your survey, you can start to prepare how you're going to analyze it. Your entire methodology is already decided, which means that everything that can be automated can be run and finished 20 minutes after consultation closes, after the final responses are in. Which means that at that point, you can start to think about, for example, policy impact, or your comms approach, or whether you need to engage with stakeholders. All those things can start much earlier. The other nice thing is that social researchers quite like it because they can spend a lot more time actually digging through text and digging through the nuance of what people find. And crucially, it means they can start writing the report very early as well. So usually it would take a full 20 working days to prepare the government report. In this case, we got it done in 8. And the other great thing was, because we'd done this automated text analysis, we had enough of a robust thematic understanding of the text that we could start to change some of the policy boundaries, which was the first time DHSC's ever done that as well. So if you're interested, the report's online. Methodology describes that we used a topic modeling and tagging system, and describes the results that we found. Things like people who want freedom of choice versus people who are concerned about duty of care. If you're interested in this, if this sounds like some of the problem you have, there's a package. It's public now. I'll drop the link in the chat. Where we've developed a whole set of functions to allow you to do this yourself. We do recommend that you have at least 1,000 responses, but I think this sort of thing applies to, for example, patient feedback. It applies to some types of staff feedback as well. So I highly recommend that people have a look. And that's me. Thanks very much.
Thank you so much. And thank you for the hard work in developing the package. It sounds super useful. And I myself will probably go check it out right after this session.
Please.
And yeah, I see that you've just sent the GitHub link to the chat. Thank you very much for that. We'll just be going through a short 10-minute break, and then we'll come back with some more lightning talks. So if everyone's all right with that, we'll just come back in 10 minutes. So that's 3:05. Hi, everyone. I think it's been 10 minutes, so we can resume the lightning talks and progress with the agenda. So can I just check, is Jay Hughes on the call right now?
Hi, Annie. Yeah, I'm here.
Hi, Jay. So he's a data engineer for the Health Foundation. A very warm welcome. Whenever you're ready, Jay, you can start your talk.
Thank you. Let me just share these slides. Can I just check that you can see those okay?
Yep, fine by me.
Fantastic. So hi, everyone. Thanks for having me today. I hope you're having a good conference so far. My name's Jay, and I'm a data engineer at the Health Foundation. My background's in maths and stats, and I have had previous roles in data analytics. My role at the moment is to support research and analytics here by building data products or tools, promoting open source working, good practice in coding, and that kind of thing. In this talk, I'll showcase the R package we've developed to prepare primary care data from the Clinical Practice Research Data Link, or CPRD. More specifically, it's from CPRD Aurum, which some of you might be familiar with, but I'm not sure. So what I'm going to cover today is quickly what Aurum data is, and some of the challenges you might find when working with it, the tools we developed to overcome some of those, and what we learned along the way, including some R packages that we found really instrumental to help us do that. And then to wrap up, I'd like to just give a quick example of how it's worked for us recently. So what is CPRD data? It's a UK primary care database. It's updated monthly, I think, and it has lots of linkages to other data sets, including hospital, mortality, cancer, mental health and deprivation data. And as of June this year, there's almost 1,400 practices in England that have been contributing data, which includes about 40 million patients overall, of whom about 13 million are currently registered. So the kind of information included is symptoms, diagnoses, prescriptions, immunizations and tests, and other lifestyle factors, and they're all recorded by GPs or other practice staff. So it's a great resource. There's big opportunities for this, for analysts and researchers to use this to help improve and understand care for patients by using this data set. But it can be tricky to get started, and there's a few reasons. There's a large number of tables and variables in this data. It's got quite a complex record structure. And to get the most out of it, you need to use clinical coding systems, which can be a bit difficult to get started with. And also the size of the data and the files themselves can be a challenge, both analytically and computationally, particularly using R, as we know the RAM constraints, and having data larger than RAM is a problem. So this slide details the structure of the data. You see there's 8 tables, and there's quite a complex relation system there where there's lots of different linkages based on different IDs around these tables. Lots of one-to-one and then many-to-one relationships. So for example, a patient will have multiple consultations, but each one of those consultations can be linked to many observations, and each of those can then be further linked to either observations or other ones, problems, referrals, or drug issues, separate tables as well. And in analysis, defining these sort of patient information based on these links is critical, really. So what does the code do? Well, the core function of the package is a main processing function called Aurum pipeline, and it works as described in this image. So it reads in the files supplied by CPRD, and it assigns the correct columns, the correct data types that they should have, performs some quality checks, and records them. And then it writes all the process data as a series of RK files, which are from the Arrow package. And then I'll go into a bit more detail on that in the next slide. In addition, there's a log file created, and it keeps track of all the operations and the outputs in case something goes wrong. And then once that's been done, the RK files can then all subsequently be used by other functions in this package for lots of other operations. For example, you can produce summary data on your sample, check links between the tables and see if that's as expected. read in and apply lookup tables to your data. And also as a step on from that, you can read in and apply some user-defined code lists to the data. For example, you can derive diagnoses or prescriptions from the right code lists. What sort of things did we learn along the way? I've got a few points here that we thought might be helpful to share. R packages are great for this type of thing. It might be daunting if you haven't written one before, but there are real benefits to organizing your work in this way. The ease of sharing and documenting your code and also testing it. You see great benefits from developing it as an R package rather than the standalone script. Although it's worth saying that package development is slightly different from how you might just write a script in R, and there are certain rules and structures you need to abide by. So it really pays to start that development workflow as early as possible in the process. And luckily, there's loads of great resources available online to get started with that. And also, there's a whole suite of packages built around dev tools, which are a great help, and I really suggest looking at it if you're interested. A lot of work on this project went into the design of the pipeline and kind of a balance between, you know, the R experience you might require for its use and the versatility of what it can do. So on one end of the spectrum, you might have a more automated push a button type pipeline, fewer, more complex functions, which might be easier to use in the short term, but it's harder to troubleshoot and harder to adapt and change and add to for different requirements. And then on the other hand, you can have a modular workflow with a set of smaller, more focused functions. And that might take more time to get familiar with, but it's easy to troubleshoot, and also it's much more flexible and you can add to it much more easily. And as requirements change going forward, it's easier to work with. So getting the balance right between those two approaches is an ongoing learning process for us. So as I mentioned before, we ended up using Apache Arrow and Parquet files for the pipeline sort of processing and storage of this data. But there's plenty of options in this space. And we considered a few different packages and methods before we settled on this. But it's Feather, which is fairly similar, RSQLite, which we actually use in another pipeline for HES data, which you may be familiar with, and DiskFrame as well. But in the end, we chose Arrow and Parquet files to make use of a few benefits, which are listed here. It's really fast to read and write, which makes it very nice to work with, and that's despite being compressed, so the files are quite small on disk as well when you've created them. If you store it in the correct structure, which the pipeline does, you can query the data before loading into your environment. So that's a great help with data of this size. And also it's a standard format Parquet, so it's compatible with a lot of systems and just allows to share across different platforms a lot more easily. And there were several other R packages that ended up being key to how we built this pipeline, and a few of them are listed here. Data table, instrumental, really fast implementation of a lot of very useful manipulation functions, which made good use of. Various aspects of the tidyverse, of course, very helpful. In particular, in this instance, Vroom is great for the text reading and assigning data types, that kind of thing. Here is really great if you're working a lot with file structures and locations. It really helps simplify that workflow. And bit 64 was very helpful as well. A lot of the ID fields in Aurum were very long numeric fields, and to avoid losing precision, and also to speed up certain joins, it was really helpful to use this package to store them in a certain way. So a quick work example to finish. We recently had the opportunity to get the entire Aurum database in our secure environment for the purposes of sort of producing our own samples for approved research projects. And the Aurum pipeline was really valuable here. And it helped us pass, I think it was around 2.5 terabytes of data through the pipeline and create a big set of around 3,000 Parquet files with all the data types defined and stored. That being done, the set is now much faster to access in R, and you can filter it to specific patients' data, based on study inclusion or exclusion criteria. And we could do that by passing that back to the other aspects of the pipeline, and then extract randomized patient samples of normally about 500,000 or 600,000 patients and all their corresponding data based on those criteria. So these were then made available to colleagues across the foundations. For example, projects here, which, without going into any detail, these are all current Aurum research projects here at the Health Foundation, and the pipeline really helped to get these set up and running in a timely way. That's it from me. I want to thank you for listening, and if you want to reach out and find out more, please get in touch. There has been a blog published on this on Medium, which goes into a bit more detail, so if you're interested, please give it a read. And also, of course, the code's on GitHub. You can install the package from there if you're working with Aurum, and of course, feel free to read, comment, and get in touch if you have any questions. Thank you.
Thank you, Jay. Very interesting. And just looking from the pipeline, it looks like a very ambitious project. And to have an output like that, really amazing work. So thank you for sharing.
No problem.
Do we have Andy South in the call?
Yeah, I'm here.
Hi, Andy. Can you try sharing your screen and see if that works, and then we can progress to the talk.
Okay. Can you see my slides now?
I can see your screen, but I don't really see your slides.
Okay, that means I've shared the wrong screen, which is a shame.
No worries. You can try resharing.
Let me try and work on that. Okay, there we go. Is that better?
Yes, perfect.
Okay, well, thanks very much, everyone. And thanks for the opportunity to talk here. It's been a really inspiring day, actually. It's great to see all of this kind of sharing of code and practice and sort of the community. I've been kind of involved with R communities for quite a while, but I'm quite new to the to NHS things. Most of my experience of the NHS is as a patient rather than as anyone kind of contributing, and so I'm really grateful to the NHS for that, and it's good to be able to contribute something. So I've been involved with this project with UCLH for about the past 4 months. And so we're looking at developing R and data skills in clinicians. So we're running a fellowship program that's a year long. We have 15 clinicians per year, and about half of their clinical time is bought out so that they can work on a project with academic and clinical supervisors. And then we're running a training program and mentoring support, and it's funded by the hospital charity, partly to promote the use of data within the hospital. And so the main aims of the program are to improve the capacity of clinicians to use hospital data, and to improve the collaboration between clinicians and analysts, and then to improve data collection and provision generally. But obviously, that's a huge thing, and this is a relatively small project, so we're kind of a small part of trying to improve that process. And my main aims today are to share our experience, point you to some of our training materials, and to seek feedback, because I imagine people are doing similar things, so it'll be good to hear what other people are doing. And so this is my my sort of super simplified illustration of what's going on in the data cycle. That clinicians are often are involved with inputting data into hospital data systems, and then the conventional process maybe would be that analysts are extracting that data and then providing feedback to clinicians. And so we're looking principally at this arrow in the middle about giving clinicians a bit more ability to use data directly. But I do as well recognize that this is a very simplified picture, and of course there's overlap between these different communities and these different groups of people. So this program was set up by Steve Harris and Waikyong Wong at UCLH. So Steve is a clinical ICU consultant and a health data scientist, and Waikyong is the Chief Research Information Officer and also a consultant hematologist. And I'm also working with May Bai, who works in the health informatics team, and I'm in to provide R things. And so a bit of history, really. Steve set up a data science for doctors course back in 2016 when he was funded by the Software Sustainability Institute. So this is a chance to give them a bit of a plug as well. So they offer fellowships of £3,000 for a year for people to kind of improve software in research. And I'd encourage you to have a look at them. It's a really great community, and that's actually how I got involved is in this as well, because Steve reached out to me through them. I think the deadline's just passed for their fellowship, but it runs every year, so it's worth looking at. So those materials were then adapted for another course called Clinician Coders, and then we're then taking them and updating them again. And so we started by surveying the fellows to find out, what their existing skills were. And so we can see that most of them have either never used R before or have used it just a little bit and aren't very confident with it. And similarly with SQL, either they haven't used it before or kind of are not confident. And also a sort of limited understanding of healthcare data terminology. So these are the things that we are sort of trying to address within the program. So all of the resources are on GitHub. And so we started by running this 2-day introductory course. And so we ran it in August. We wanted to run it in person, but cases were quite high at the time, so we ran it online. And these are the learning objectives. So I'm sure you'll recognize some of these, becoming familiar with R and RStudio, some things about sort of general good data practice, a little bit about dplyr, ggplot2, and then a very brief exposure to R Markdown and Shiny. And this one, for me, this one at the end really is perhaps the most important, is to give people a feeling for the potential of R and a motivation to learn more. So I just stuck this slide in at the last moment really to remind myself, because as well, these are clinicians, then they're probably never going to be full-time, data science people. They need to fit what we're teaching them into their own kind of very busy and important jobs. So it's, what we're trying to give them are good enough practices, maybe, rather than sort of cutting edge best practice. The course materials, as I said, and the schedule and everything are online here. So there's a link. There's sort of a folder of instructions. This is the schedule for when we ran it across 2 days. So, mostly this was set up for us to run it, but we have put some instructions in there if people want to run it in a self-guided fashion, which will take you through sort of step by step how to create a new project in RStudio and to be able to download the repository from GitHub so that you've got it as a project in RStudio, and then the project in RStudio looks, with the same folder structure in here, and so the sessions are in there with a series of R Markdown files that generate PowerPoints and some R scripts, and so that's how the session works. Let me try and go back to my slides that are hidden behind the sharing button. I'll get there in a second. Right, so the post-course evaluation, yeah, people seem to think that the course level was about right. I probably could have done a bit better following up people to get evaluation responses, but that was good. And you know, we're really keen. We're really pleased to see that people were keen to learn more about R and kind of said that they thought it was achievable and it would be useful for them. So the fellows are now going on working on their projects. This is a selection of different projects that people are working on. And we've got common themes really about extracting data from hospital systems, being able to identify cohorts of patients with particular conditions, manipulating the data, and then perhaps identifying problems with the data entry process that can then be improved. And we're also, working out what are the best workflows for what are good workflows for the clinicians. Is it better for them to work in tandem with analysts to extract data into sort of tables that they can go on to analyze in R, or are they able to do everything themselves in R? And this is something that we're all learning as we go along and trying to develop something that's kind of reusable out of that. So thanks very much. Yeah, I think I put the link to the slides in the chat, and there's also the link to the repository here. Have a look, and yeah, do reach out to us. So thank you very much.
Thank you, Andy. That was brilliant. Training is so important, and the fact that in the evaluation they all said they're keen to learn more is so encouraging. Very, very happy to see that. All right, thank you, Andy. So moving on for our last talk today, we've got Lydia Briggs. Hi, Lydia, if you're online.
Hello.
Hi, so Lydia is a data scientist for the Great Ormond Street Hospital NHS Trust. And I'll just hand over to you, Lydia.
Yeah, thank you. So thank you for NHS-R for having me. I'm Lydia. I'm a data scientist for the digital research environment here at GOSH, and I'll be talking about an automated data processes in clinical operations, specifically looking at the cardiac M&M meetings as a pilot study. So just as a bit of background, the cardiac morbidity and mortality meetings are, they meet every Friday. It's where people in the cardiac department discuss surgical cases and complications which have occurred throughout the previous week. The data they present is done like a week in arrears. So currently the analysts, they get the data by manually reading the patient's doctor's notes on a daily basis. So it takes quite a long time for them. It's thought by incorporating the DRE and forming this project that automation could save over 11 hours a week by using our data extraction processes and wrangling the outputs. So not only is saving analyst time a big motivator for us, but also we want to add value where we can. We want to do this by making it easier to link data together, by creating informative visualizations, reproducible data extraction, and ultimately make it an automated process. So the project took this kind of view. It started by identifying the patient complication features of interest using their current presentations as a template. We then want to source the data and use our data extraction processes, trying to move away from unstructured doctor's notes where possible. We then generated automated analytics in R and developed a tool to present the information to them. In this case, it's a dashboarding project using RShiny. And then we want to validate using their current processes, like the manual presentation that they use at the minute. And this iterates through to try and make a full product. We also have this feedback loop here to try and incorporate advanced feature engineering to introduce additional features, which we think might be useful when they're discussing their cases. So just as a little bit more of a look into the extraction, we as the DRE have developed a data engineering library, and we've incorporated into the R project by using a targets pipeline for reproducible workflow, and we use Reticulate for the interoperability between R and Python, with our end as well. The output of the extraction are what we call research data views. And these are essentially like tidied data structures from the raw extract from Caboodle, which is the back end of the electronic patient record system. In terms of linking data together, this project uses 9 research data views, including information on ward stays, host admissions, theatre lists, etc. And it becomes quite easy by using like data methods of joining a lot of information together on the patient level. We also include external data, for example, from NICOR, and also we read in any manual spreadsheets that the department maintain and want into the project. For example, their cancellations data. So this project is currently in the process of being handed over, and the team it's being handed over to, I wanted to develop the project in a way where it's really easy to update and use for people who are not so familiar with R, or perhaps not coded in R before. So the extract is governed by one simple adaptation to the pipeline with the target called Presentation Friday shown here. So they can update the extract just by changing this string in this loop date function here. And you can see all the other dependencies like allow on that. So because we're using targets, like I said, this then trickles through the pipeline, and it once they run tar make and tar load, and then everything is updated. So the patient list in this case is defined as all patients who have stayed in the cardiac wards. In this case, it's a cardiac intensive care unit, and also the Bear ward. So in terms of validation, it goes without saying that Presentation Friday and all of these dependencies, it could be more live. So these meetings happen on a Friday. To help with validation, I have included, or I've incorporated how they do all their timelines. So for example, the patients in the wards are calculated on the Tuesday of the presentation week, and their complications are calculated from the previous week. So that's why we've got weekend. But we can update these, as this is now an automated method. So they could have data as of 20 minutes before the meeting if they really wanted to, which is another positive. In terms of targets as well, I've used a common naming convention. And because this is like being handed over to people maybe who are new to R, every single target is, every single output, sorry, is a different target. So I do the plots, the tables, and the manipulated data frames as different targets as shown here. So this is an example of the low cardiac output state complications, specifically for ECMO. You can see we've got the Wrangle data frame where we join different data together and mitigate for the cutoffs. We've got different plots and tables as well. I've also incorporated various functions depending on the audience of these talks. So we've got a remove patient names function in the wrangling of the demographics RDV, which essentially it's a toggle between demonstration mode, which is what I'm using that you'll see in a minute, and also where it shows the like PII, so personalized patient information. If a user's using their full name for if they're using it in the cardiac and then meeting. I've also mitigated for cases where the data is ahead of the cutoff dates for the previous week, just by dummying the end dates, so, which you'll see in the timeline plots in a second. So if I just quickly jump over to a short demo, I'm just going to run the app. So the landing page is this overall tab. So I use plot the outputs with informative tooltips and data table outputs here, which I'm sure we all know. We can like filter the data that's presented. And it's incorporated with the these radio buttons to flick between the wards of interest, so Bear and CICU, just here. If I now go to patient length of stay, this is really useful. You can see here that this otherwise would be manual. So it's where the analyst would go into each of these patients, this is in anonymized mode, and look at their doctor's notes or any information on a daily basis. So it's quite time consuming. What we have here is trying to bring lots of data together. So day 0 is this presentation Friday date, which I've just pasted up here. I've just used an example from October. So we're starting to layer our data together to try and get a picture of the patient's journey. We've got hospital admissions linked to ward stays, so bear in CICU with your tooltips, and I've also overlaid on patient procedures, so surgical procedures that the patient have had. And this like tracks their history, as it were. If I just show you now an example of a feature of interest. So we're low cardiac output state, we're looking at ECMOs, and similarly, we're just like layering on additional information. So this is when the last ECMO was. And again, it's a timeline plot using day 0 as your, is when the event last happened. If I now show you one for the neurological complication of infarction, it's really, I found it very important to source where the data was being held on the electronic patient record system. So I found this one in a range of places, essentially. So I found it in the problem list and also in scan summaries. So this is where I'm joining more data together, but it's still only presenting itself as one feature of interest, as this cross here. So this one's shown from an MRI. I think there's one down here from the problem list. So you can see that information shown here. So we're just layering up the information, essentially. You've also got demographics information. So just quickly switch back to this. It opens up the question that the data, well, yeah, the data that's been inputted into the EPR system is the data that I'm reading out in this tool. So I, like in terms of validation, I've created a like confidence rating. So anything that's like, you know, numerical data, you know, it's really structured, it's, you know, inputted really reliably. I've given it a really high confidence rating, such as the ECMO, which is a procedure. We've got CVVH or PD, which are renal supports, that's in continuous data as flowsheet rows. But anything, for example, like the infarction case, where it's in unstructured data, so as the summary of scan documents, because I've incorporated text mining and pattern matching, there is the like potential that it doesn't carry through into the app, because at the moment this app does not include any sophisticated NLP or processes like that. So we're in continued talks with, you know, the hospital for like yeah, how we can really improve like data entry and data capture. So to summarize, I've automated the capture of the data for the cardiac M&M meetings in a reliable and reproducible workflow. We've got the extraction automatic with only that quick change in the presentation Friday. And the plots and table outputs can be refreshed with just reloading the change dependencies in the targets pipeline. We've included the easy linkage of data, so more information is presented in the same place, and hopefully we've done that through those timeline plots. So instead of data being in different tabs in the EPR system, we're kind of collating it together with informative tooltips and a plotly output. It's easy for users to refresh the data. Like I said, we've just changed in presentation Friday, and it's estimated that would save, well, it's got the potential to save over 11 hours per week. With doing the targets pipeline in the way I've done, with every target is a different, well, every output is a different target. I aim to use this as like project learning materials. So ultimately, while we're all here at NHS-R conference, to encourage more people to develop in R. Yeah, and just acknowledgements to my team and everyone who's helped me with this project. Thank you very much.
Thank you so much. And the dashboard honestly looks amazing, and also such a good example of how you use the targets package, because it's a package that I actually learned just last week, and already I have a brilliant example how to put into practice. So I'll definitely be checking out your code.
Definitely, thank you.
All right, so that concludes our lightning talks. Thank you to all the speakers and to everybody who attended the session today. I'll just hand over to Mohammed, who will give some closing statements for the end of this conference. Thanks, everyone.
Thank you, Annie, for chairing the afternoon session, and just to echo really that an amazing breadth of talks, an amazing breadth of applications, going from kind of very local use cases to publication standard material, all very valuable. And I suppose really from my point of view, it's really finding a way to scale up these things to other parts of the National Health Service. But a big thank you to everyone. I've just posted in the chat really that if people can join tomorrow, so although the start time is 9:30, if people can join a few minutes early just to allow some of those kind of warm-up things to happen. And tomorrow has an international flavour, and one of my heroes from the world of statistical modelling, Frank Harrell, is very kindly agreed to speak to us tomorrow. So we look forward to all of you joining tomorrow. I wish you all a very good evening, and thank you to all the staff who've helped behind the scenes as well. So time to sign off, everybody. Thank you very much.